All right, it's almost time. We are 1 minute early. So let's wait for everyone to join in. You know what? Let's get started. Let me check if you guys are in already. If you are here, if you are back from the break, can you put your favorite emoji in the chat? Or an emoji that describes how you're feeling right now. Okay. How are you feeling right now? Are you excited? Are you pumped? Are you thrilled? What are you feeling? Can you put that emoji in the chat? That also becomes a way for us to know that you are back from the break. If there's no answers, huh?
I'm seeing some hearts
Okay,
and some thumbs flying around, but nothing like
amazing. Yeah, there's a lot of claps, there's thumbs ups, there's laughs, there's hearts, there's crazy face. There's a face with stars in the eyes. Okay, good, good. Well, it seems that everyone is back in that case. It's also time. Let us quickly get started. Well, let me introduce you to the next speaker. She is the powerhouse and the brains behind the Practical AI Summit. She's the reason why we are all here today. With more than 20 years of building enterprise systems and AI products, she has founded AI Foundry to help businesses turn their crazy, crazy ideas into AI powered solutions. And that too really fast. So, from launching EquityResearch.ai to now helping founders turn their wildest idea into working AI products, please welcome your host and our founder to talk about AI cost, Sangeeta Bahri.
Thank you, Deep, for a wonderful introduction. Hello, everyone. It's been a great day one and day two, and I'm really excited to go over with my presentation. What I'm going to talk about is the true cost of consuming AI. Just give me one sec. I'm seeing something strange. I'm not seeing my present. Oh, yeah. So we are in a period of intense excitement around artificial AI, right? Nearly every company is talking about AI. They want to adopt AI, and that creates pressures for everyone, right? And however, a poorly executed implementation can be very costly for an organization. So how should you go about it? So this session is going to go over a few things. It's not going to talk about the magic of AI. It's going to talk about math of AI. So we're going to pull back the curtain and talk about the true cost consideration behind these powerful tools, so you can make a informed decision about your organization. So we're going to talk about why can't we just build our own AI models, the true cost of consuming AI, walk through a practical framework of optimizing AI cost with a case study, also some strategic takeaway for your business that you can apply and implement AI solutions. Why can't I just build my own version of ChatGPT or my own AI? We've all seen ChatGPT and other AI tools creating amazing things, and maybe a thought crossed your mind. Why can't we build our own? Building something like ChatGPT model is a complex task. It involves extensive computational power that only large data centers can provide. So it's very costly. You need to have a lot set of data. You need to compute. You need to have talent. You need to have infrastructure, ongoing operation costs, responsible AI. I think you've heard about each of these topics from different leaders in day one and day two. If you look at it from 2017 to 2023, the training cost has risen quite a bit. It has gone up from a million to about 191 million. Infrastructure cost is about like 5.2 trillion. Daily cost of just running ChatGPT is about $700,000 per day. So you can see, how expensive this is to actually create and run your model. So so what we going to talk? What are your options? Build. We can talk. I'll talk briefly on when you should build, but this talk is more about consuming, because most businesses don't need to train a model from scratch until unless your problem is such that your data set is very different, your patterns are very different, and there is nothing out there in the market that is going to fulfill your needs. So that's when you want to look at building. So, and I know that 95%, okay, I'm jumping a little bit. So how do you decide? How do you decide which one should I pick? So look at the ladder of effort. So prompt engineering, thinking of is like a takeout. So if you can customize how you ask existing model to get what you want. So they are very low cost. You can do ChatGPT, OpenAI APIs, Claude, Gemini's. Think of fine tuning RAG, where you want to give your own organization data. You want a tone in a voice, so you feed your data to it. It can be a RAG, it could be fine tuned and existing. It is also costlier, but not as costlier as building your own model. So your own model is basically launching your own restaurant, which you can imagine what it can entail, from takeout to hiring a chef to a restaurant. So I'm pretty sure 95% of you will not be making your own AI model. Like I said, unless you have a very specialized unique data where there is no AI model available and then you have to build. So where we will be discussing true cost of consuming AI, not building AI. We are not talking about deep technical development. We are talking about the AI tools and services we use every day. The OpenAI, other AI APIs. These tools offer immense power to transform your business, but there is a rapid adoption price brings unique cost and risk that we as leader must watch out for. Say, for example, a team uses Gen AI to summarize support transcripts, cutting time down to 40%. Great, awesome. Yet one faulty script scope could create thousands of summaries, and there could be a 20K surprise bill. So we need to be very careful how we steer this powerful wheel and not let it run wild. So our goal today is threefold. How do I optimize my operation expenses? How do we control the variable usage-based cost of these external API AI services? Measuring productivity. How do we ensure these investments truly deliver measurable business value and productivity gains, not just perceived coolness? Managing oversighting the third party models. How do we manage the risk relying on external AIs? You've seen it, data compliance, vendor relationships. So how do I manage all that? The core cost model is the token economics. I'm not sure if you are aware of it, but you might have heard tokens, right? Uh, at the heart of consuming AI APIs is something called token economics. Think of it token as like a word or part of a word. When you use an AI model, you are charged based on the number of tokens. So token are unit of text, say word, subword, punctuation. One word might be broken into multiple tokens. So input tokens, they are tokens you prompt. So any question, any data you send to the AI, that is an input token. Output token is what you get a response back from AI. So uh, critical thing is that output tokens are actually 2 to 4 times more expensive than input tokens. So you can understand you have to be careful with what you send, what you get. Context window size is this is the model working memory. So how much information it can process at one time. Of course, a model that has bigger context window is going to charge you more. So basically, billing is based on your total number of token processed, input plus output. The other variables are the other hidden variable cost of quality, model choice. Do you need an absolutely bleeding edge model like ChatGPT VO for every task? Often a slightly significant lower that has less value in terms of money is better model for you. So you need to really decide which model to use. Might be a better, cheaper option for you. They are allow small learning models. So you don't have to use those big, large learning models. The small learning models can actually even solve things for you. Think of it like a simple task where it's like buying a supercomputer to run spreadsheet. It's overkill and overspending. Make sure your input and output ratio match. You don't want to you want AI to give you a short answer, but you don't specify the range that you want. And so it gives you a lot of verbose. So you are spending cost there. Some models, offer lightning fast responses, which is great for real time interaction. But what if you have a large scale, non-time sensitive stuff? Do you really, whereas you have to summarize thousands of documents overnight? So there's no point using a real-time, more expensive model to do that. You can do this offline. So they are like, do it in batches, so that helps you save some cost. Next, I'm going to talk about vetting the third-party tools. Very important. You want to make sure there's data privacy, there's compliance, there is very careful about their pricing. Once you're logged in, what if they change the price on you? How are you going to manage those things? So, and how are they intellectual property violation of any data data policy that your company complies with. So you need to make sure when you pick a vendor, you vet these things very nicely. Again, measuring ROI, the productive first approach. Now let's talk about payoff, meaning return on investment. For Consume AI, our primary focus is productive ROI. It's about converting time and effort saved by AI into measurable financial gains. This formula is simple, right? Time saved multiplied by an hourly rate minus the AI cost divided by the AI cost. So let's take an example. Before AI, say each sales manager spends about 2.5 hours every week manually summarizing their call logs. Now using an AI API like Gemini for summarizing, they spend like half an hour, and that's basically saving 2 hours per manager per week. And say you have 50 managers, and their loaded hourly rate is 75. So there's a direct saving of like $390,000 annually, which can be reinvested into your business. This kind of measurable impact we need to measure and demand. But there's a challenge. Now, say you implemented the solution and you look at the real data and find the value gap. So there can be a value gap. So say you're noticing that 90% of managers are using the summarization tool, great. But when you look at their schedule, it's just dropped by 30 minutes, not 2 full hours. Why? Because they're still reading the full log just in case, or they find the AI output slightly too generic, requiring heavy edits. So the outcome in this is we are still paying full API cost, but our realized value is only, say 97,000. So this is actually a big difference in saving. We are not really saying saving 292,000. There's an unrealized value, there's a value gap. So I'm just going to go over with a case study of equity research. It's a stock analysis platform. It's meant for a retail investor who want to invest, who face problem not getting good financial advice, who don't have good source of information to self-manage their investment. So what equity research provides is unbiased, easy to analyze any company stock, and it's using data, AI, proprietary evaluation model, and provides insights to its end user. So what happens is somebody comes in, they give a company name, the stock analysis will generate a report for them. There will be some fundamental data in there highlighting different fundamental metrics. They can look at different charts and make an informed decision about what they want to do with this particular stock. We also built like a WhatsApp, a Telegram, and a web chat feature where they can again ask the bot anything about the company, right? What are my what are the competitions? Should I buy? Is there insider buying happening? Can you give me the quarterly report of and convert a quarterly report into a podcast and things like that? So when we first built equity research, every user query went straight to the external LLM API. It worked, but the true problem quickly surfaced: high token wastage. User asking this, we noticed the user was asking the same question over and over, and we were just burning tokens, answering the same questions. We also noticed there were a lot of static data. The data was not changing. Like, for instance, the quarterly data doesn't change for that quarter. And also the quarterly earning report doesn't change for that quarter. We also had like different vendors. So we tried different vendors in terms of their pricing and what we were getting. And so we were like, okay, now we had to change. So that was a tricky thing. Okay, now I want to change the vendor. Required us to make a lot of changes in our design. Yeah, I talked about it. Okay, next slide. So we applied the optimization framework. First of all, we optimize our input. So we cut down the data being sent to the model. Instead of dumping long, unstructured documents, we cleaned up, structured them, wrote very concise prompt. And also, we just didn't write one prompt, there were multiple prompts. So we also started benchmarking each prompt. And that was very helpful because one time what happened was we made a change to a prompt and didn't realize that we started sending some data that was not required. All of a sudden, like where our cost used to be like few cents for a call, it went to like close to a $2, and you're like, what happened? And then we realized, looking at our code review process, that, oh, you know what, this data should not have gone, and since that is going, I think that's causing it. So we then started putting benchmark into each and every prompts that we were using and kept improving the prompts. Same thing we did for the output control. We made sure we had like strict token limit. We were using different models for different prompts based on what we wanted for them. We evaluated different models to see what we are getting. We built an intelligent layer as well, which could actually do smart caching, could route the layer where there was static data. It was just getting it from our database wherever we needed to make a real AI call is where we were actually making that call. Wherever we could optimize, things were not changing. We had put in our database and we're getting from there. So this actually really dropped our cost from like $2 to like pretty much 2 cents. Basically a big reduction for us. So this is the framework which is repeatable. I think in any businesses, you can use a caveat of this. You can add or refine it based on what you're building. But these are very foundation AI consumption playbook that I'm going to cover next. Okay. All right. So before you're implementing any optimization, if you already have deployed AI or AI tools, the first step is to actually immediately audit. You need to find the shadow AI, the unmanaged, unmonitored use of large models across departments, because these are the projects currently running up the highest billing and posing the largest risk to your chaotic token usage and lack of governance. You cannot optimize something you cannot see. So first of all, let's control the input token, the information we send to the AI. This is where we have more direct control over the volume. The challenge, imagine our equity research example. If every user query about Apple Q3 earnings sends entire 50-page earning reports to AI, we are paying for the same 20-page repeatedly. This is massive waste, right? So verbose prompt. If our employees are writing lengthy, unoptimized instruction to AI, they are sending more input tokens than necessary. Increased cost per query. As a CIO, maintain an intelligent layer architecture, just like equity research. We must require an architecture layer that sits between your application and external AI. This layer job is to intelligently filter, cache, deal with duplicate data. If the data hasn't changed or the question has been asked before, it serves the answer without hitting the expensive external AI APIs. Sorry, my computer just froze for a minute. Sorry. Enforce prompt engineering standards. We must elevate prompt writing to a skill set. I think this is a skill set of AI that everyone should have. Prompt engineering, context engineering, mega prompting. Invest in training your key users to develop concise and specific instructions. The second, we must control the output token, the AI response. This is where the cost can quickly become a runaway train because output tokens are often 3 to 5 times more costlier and expensive than input tokens. The challenge, like I mentioned, right? If you ask AI a simple question and it generates large multi-paragraph response when a single sentence would suffice, we are overpaying significantly. This leads directly to unexpected budget spikes. A model of over specification. Again, using the most powerful premium AI model for every task is not really required. Even simple summarization or data extraction is like driving a Formula One car to pick up groceries. It's a massive overkill and unnecessary expense. As a CIO or a CTO, implement API output limits, decide enforce tier model strategy. I'm running out of time, so I'm going to be fast because there's plenty to cover. So the final pillar addresses the challenge of making AI spending transparent and financially accountable. If you cannot measure it, you cannot optimize it, and you cannot certainly budget for it effectively. So measure benchmarking, closing the value gap. We discussed value gap earlier. The difference between what you could save and what you are actually saving. Benchmarking is how we fix that. You need executive dashboards that can track core metrics like cost per interaction, time saved per business process, accountability, eliminating the black box. The biggest frustration for finance and business leaders is that the LLM costs often arrive as a single anonymous cloud bill, right? It's a black box and nobody owns the spending. So you must track every API use, tag those expenses directly to a specific business unit or department using the AI. Certainly, the marketing team is this transform AI spending from IT is not just an IT expense. It should be measured, and it should be a departmental expense. Certainly, the marketing team is accountable for LMS uses, and R&D team is accountable for theirs. This level of accountability ensures that the budget is disciplined, strategically aligned, guarantee the expensive LLM resources are only used when they deliver high proven ROI. This is, we covered the costs, seen the saving proof, outlined the framework. Now, here is just a practical implementation plan that you can put in action and start realizing optimal ROI. This is a phase implementation that, you can define the timeline as is feel fit for you. Basically, currently audit current users, input token optimization, output token control, executive framework as to how everything will be get evaluated using the dashboard, ROI, measurement protocols, and things like that. So yeah, this is the practical framework to optimize, to pull this all together. Implementing the AI consumption playbook is not just an IT task. It's a strategic framework that addresses the most critical challenge facing every business adopting AI today: cost management, risk control, and maximizing volume, maximizing value. I'll move on, but I want to keep time for Q&A. Yeah, so some of the strategic takeaway for your business as we conclude our discussion on true cost of consuming, I want to leave you with 5 strategic takeaway that you can implement in your business immediately. Start smart. Use existing AI services before considering costly bills. Don't overspend on premium models when educate ones suffice. Measure what matters. Track ROI in productivity and outcome, not just bills. Control the input and outputs. Optimize token, prompts, model. Build an intelligent layer. Structure data, cache, prevent runaway cost. Implement in phase with oversight. Audit, optimize, manage output, track ROI. Hiring the right talent, that's also very important. Train your team and hire with AI skills. That's all I have.
Okay, amazing. Thank you so much, Sangeeta. Well, this was amazing. Mind-opening to say the least. Thank you so much. And I see a lot of claps and hearts and thumbs ups in the chat as well. So there you go.
Thank you. Thank you.
Okay, let me read out the first question I see here. Kai says, do you use any of the principles of reinforcement learning to create novel prompting or meta prompting?
Actually, no, not in this case, because we were answering the question that user are asking us, right? So their questions are our input prompt. So that's what we are feeding it. We are adding our own prompt to their questions, but there is no, I mean, we defined it quite a bit at our end to get to give good responses back, right? Okay, somebody's asking me this, but the response is this. No, not that doesn't make sense, right? So we had to tweak our prompt, okay, because we knew this is a better response to this type of question. So when we were building our platform, that's what we did.
To standardize the response that the AI gives to the user.
That's correct. Yes.
Amazing. Okay. Gary says, how did you track the cloud cost? Did you use any tool?
No, we actually used the dashboard and analytics that the vendor itself was providing, and so we had put in for each and every prompt, like, or interaction that we had built in our system. We've segregated them as different projects or different features. Call it features. So every feature or everything that is using is separate in the vendor side, so we can track which ones are getting used by how much is the input token going by for each and every request, what is the output, and that's how we were measuring it.
Amazing. Thank you. Nishant says, how much of the reduction incorporates upfront data cleansing cost?
Data cleansing cost. We didn't have, like, our data was like stock data, right? So stock data is what daily high low, what is there. We are getting data from a third party vendor, all the financial data, right? So that data we don't have to clean up. It's a clean data that we are getting. So there's no cleanup of data from our side in that sense, but we are using only some of the things that actually matter in doing the analysis for our model. Yeah.
Okay, very cool. Jason says, when building your equity research app, how much trial and error was involved in terms of what AI tools you used?
Yeah, so trial and error, yeah, we tried different models and saw their output and evaluated their cost, and that's how we went about deciding which was giving us better output. If they're giving similar output, which one is cheaper? Like, why pay more for something that they both work the same way? And yeah,
Yeah,
and
amazing question, Jason.
we still evaluate. We still evaluate on ongoing basis. We have the benchmark. We see if it's changing anyway with new stuff that comes in.
Yeah, that's an amazing question. I have a follow-up if I may.
Sure.
What would be the most important factor that you would look out for an app like equity research? What would be the number one factor characteristic you would look out for while deciding which LLM to use?
The one
Apart
that
from
can take,
cost, of course.
yeah, no, something that takes the data that we are giving it, and it can give us real and stand and saying, okay, I want my output to show in this way, this thing, and it's actually giving me everything relevant and not hallucinating. And when the
Mm.
users are also interacting with it and asking questions, and it remembers the context, it remembers the things, and is giving us a good response, and educating our users in the right way.
Okay, fair. Okay, one more question. I think we can take this. Mithil says, learning from your experience, how would you implement a reporting function for a CTO or a CFO if you were to start afresh?
If I were to start afresh, I would, look at one problem at a time, not just try to build everything in one go. Take one thing at a time, and then make sure you build some kind of a dashboard. Provide, okay, this is what we are using, and this is what the report will look like for our CTO or CFO or CEO, and so that they can measure both the productivity. Even when these days, our case is a little different, but today, if a lot of companies have Chat GPT license or XYZ licenses, how are they measuring the productivity? I know yesterday Igor talked about productivity of developers, but in your organization, you should also think about how we're getting these tools, but how are we measuring productivity of different positions in our organizations, and build something or find something that measured it and give reporting to that.
Okay, very cool. We have one more question, but I don't think we have time. So, well, I'll pass it over back to you. Thank you so much. This was amazing. Great learning.
Thank you so much, Deep. All right, do we have our next speaker? Yeah, I do see Dan is here. Awesome. Right, I will introduce him. Did I stop? Yes, I did. Okay. All right, I'm going to introduce our next speaker. 20 years at ESPN, Shutterstock, Viacom, NBC Universal, and that's just the beginning. An engineer turned product leader who builds highly cross-functional teams that ship. Welcome, Dan Mason. All yours.
Great. Thank you, Sangeeta. Nice to be here. Looking forward to sharing a little bit about a recent project with you guys. I will say up front, this is the 20-minute version of a 2-hour talk. So I'm going to do my best to keep it short. But the version of this talk actually is out on YouTube. So if you're curious, I'm happy to point you to that at some point shortly in my presentation. Okay. So I want to start just by a tiny bit. I'm giving you a tiny bit of color on Stride. That is the consultancy that I work with. And then I'll tell you a little bit about the project and show you some actual real code. Or in fact, in this case, just the application itself, and then I'll sort of allude to what the code's doing. So first bit, Stride is a custom development shop, a consultancy. We offer a handful of different types of services, some strategy, product management, things like that. But our primary reason for being is builds. We do a lot of interesting build work, in particular around AI. So I'm going to show you a version of what we do around agent workflows. But we also do AI enhanced code generation, things like test building and application modernization, all using AI as a backend. What I'm talking about today is specifically something we did in the telemedicine space. This is a pretty interesting example of a case where there was existing software which essentially did the job that I'm about to show you being done by an LLM and sort of some software associated with it, but fundamentally was doing it less efficiently with in sort of more brittle ways and with a lot less scalability than what we're able to do when we incorporate LLMs. So it's the best kind of problem where they already knew they could solve it, they just wanted to solve it better, right? And so we came in to help them do that in this case with LLM support. The first thing actually is just the company themselves. Thank you to Avila. Avila is my client. They're willing to let us talk about all this, which in the world of custom software is not always possible. So I'm really thrilled that they allowed us to share this with the world. Avila is specifically working on the treatment of early pregnancy loss, otherwise known as miscarriage, trying to help really with what happens essentially when women are treated, after the event. So they go home, they have medicine to take, right? This medicine has to be administered over a period of days, right? It's not something you take all at once. They also may need support just with dealing with symptoms, dealing with, the overall sort of thing that happened. And so really what Avila is trying to do is provide a service for those women who can then, essentially go to Avila instead of going to their doctor who may have limited capacity, who may not be equipped to answer all of their questions, and doesn't have this kind of system to support the overall medical treatment. So I want to talk briefly about what it took to do this and sort of what stack this is on. I won't go too deep into these details. The first bit, we did all of this in the LangChain ecosystem, LangGraph, Langsmith. You'll see both of those in some form in the next couple minutes. We are using Sonnet. And we have not upgraded yet to 4.5. We're still thinking about running the evals for that. But fundamentally, we are using the latest and greatest models. That is one sort of principle of building these systems, is that especially when you're talking about things that don't have to operate at massive billions of users scale and that actually have some amount of turnaround time, which you'll see in the experience. use the best available model. It's the best choice, in most cases. And it allows you to really focus on the workflow, right? As opposed to sort of tricks to make the model perform well. But the code that we wrote absolutely runs in OpenAI and Gemini. We've tried it in both of those cases. We just really like Sonnet better as a steerable model. The stack otherwise is pretty standard. It's a Node and React app on the front end. It's got MongoDB involved. The LangGraph container is a Python container, and we're doing text messages. So this is a text message based system. So it goes through Twilio. The whole thing is hosted in AWS. It is very portable. We can deploy this in any AWS region. Again, really all we depend on is having access to Claude. Otherwise we can deploy the entire stack in a box. For evals, we chose to build something custom. In particular, in our case, and you'll see this when you see the experience, the reason for that was primarily because we had to do a lot of creative stuff with time. And if you think about what you're doing with LLMs, right? You're saying, here's my context, and I want you to sort of, deliver an output, and we kind of can compare those outputs in this case, an LLM as a judge context. It gets very twitchy when a lot of what you're trying to figure out is, hey, here's the current situation for this patient. When should they take their medicine, right? There's sort of math involved. And so a lot of what we had to do to build a custom harness was around this idea of making sure that we could test whether time judgments were happening correctly. So, every application is going to have a different version of this challenge, but that was ours. So we have a custom harness that essentially, compensates for that issue. And then we use PromptFoo, which is an interesting package, really just to visualize the results of the evals. And we're using LLM as a judge, meaning we generate the output that we expect, and then we use reference output essentially and ask an LLM, hey, what's different, and do the differences matter? And then we have humans as well involved in the process. A lot of what I'll show you here is the human in the loop, right? That's a very important part of this system. The team was basically a couple of engineers building what you'd call the conventional software, a designer helping to, overall shape the experience, and then me. And I was kind of, filling in a bunch of these gaps, but I really was building the workflow, right? So we're an agile shop. We work in, extreme programming contexts all the time, pair programming, things like that. We kind of naturally formed into, these sort of teams, and my pair really was the code agents. And so most of this that you'll see, at least on the graph side, on the the LangGraph side, was me coding with, in my case, Klein. Klein's the one that I like. All these agents are out there. This list is kind of dated, to be honest. I use Klein. That's the one that I personally prefer. But agentic coding really is real. And if you have not embraced it, I'm a former engineer, so it's one of those things kind of easier for me to embrace. But it really did enable us to do this in a very short time frame, and fundamentally, I think, with a pretty high quality bar. So happy to talk more about that. Really briefly, I just want to be clear on what I mean by agents. I'm not sure how much this has come up in the rest of the talks. To me, an agent is really just using an LLM to decide control flow, right? So it is not that, the LLM fills in gaps, it writes blog posts, it creates content. In this case, we're giving the LLM the power to decide what the application should actually do, right? That is a pretty powerful concept, and you have to build, the appropriate systems around it to make sure that everything works in the end. And part of what I wanted to share here is this framework, the idea of AI agents in production really do have to have a combination of these factors: capable, transparent, and controllable, steerable, right? If you don't have any of these things, you end up in a bad place. It's either dangerous, frustrating, or useless. And a lot of what we did with this framework was to build each of these, right? It has to be able to do the job. We have to be able to see it doing the job, and we have to be able to steer what it's doing. That really defines how we put this together. So I want to start actually just with the case study itself to give you a sense of the problem we were solving and the business outcome we were going for. So in this case, to support patients taking medicine regimens, right? So again, this case of early pregnancy loss, there was a team of existing human beings running essentially a telemedicine operation, right? And they would receive text messages from patients, and they would have to use the software that was in place to dispense what amounts to medical advice, right? Here's your situation. Here's what, the doctor says you should do. It was a very brittle system because, as you can imagine, you couldn't have free-form text messages going out. You had to have a very specific number of responses, and you had to have a very controlled workflow about how those responses were generated. So scaling both the human team and the systems was expensive and fundamentally unworkable. So what we did was to basically take the business logic that existed in the old software and re-implement it in the context of what we call a blueprint. But basically, you can imagine that there's a pretty complicated flow chart that goes along with dispensing, a medical regimen, right? And, there's, different things that can happen in different places. You might end up looping back around, right? There's a fair amount of interesting outcomes that can come from this process. So we created something that was legible to LLMs that expressed the logic of that blueprint, and then also express the knowledge that's contained in knowledge bases and sort of, the larger set of information that might come up in a conversation, because part of this is just giving general support also to people who are going through this treatment and this experience. We had this concept of self-evaluation, right? So LLM agents being able to flag responses that they thought were lower confidence, and I'll get into how we did that. And then again, human in the loop was really important for both giving comfort, to the operators of the system, that they were able to see what was going on, that they were able to intervene. And also it really changed kind of the scale equation in a good way. And so the impact really was that 90% of the time, the system we built is able to handle situations autonomously, right? Still transparent, you can still see it, but it's able to say, well, I know what the situation is, and here's the response that I should give, and that response can automatically be delivered to a patient, right? Whereas before, every operator, right, the human, had to click a button to make that message go out, right? That no longer exists. We don't have to click those buttons anymore. 1 out of 10 times, roughly, it is good for a human to get involved, either just to approve what the LLM's doing or to intervene, right? And so fundamentally what you're getting is now this operations staff that can support a lot more patients. And I can't show you a great example of this, but please take my word for it. You can support new treatments and new workflows without code. It really is just these blueprints. So the version that I'm going to show you here is around women's health. We also did a version for Ozempic that works pretty great. And it was literally just a new set of documents. So that's the outline of it. Let me show you a couple of details. So the first bit is that this is a LangGraph flow. It's a pretty simple one. So, this is just one step away from what they would call the React agent, which is basically just an LLM with tools. But the idea here is that this virtual operations associate is fundamentally doing the job in terms of determining, based on a patient's situation and what they just said, what to say and what to do next. We replicated that flow in an LLM. We gave it then access to what we call an evaluator, which is then going to look at essentially the situation and the decisions the virtual A wants to make, and give a confidence score and basically say, look, this is a clear-cut case. We should just do it. Or this is complicated enough that it would be great to get a human involved, right? And then that is reflected in essentially the human tools that we built. And to give you a better sense of the architecture, this is really the system we built, right? So the blue stuff is conventional software. It's Node, it's React, it's MongoDB, whatever. And the beige box is the LLM, right? It's this LangGraph, along with these blueprints. And there's, again, text messages coming in and going out. Like, that's really the way that we interact with real patients. But this OA dashboard in here is what I'm going to show you in a minute. It's essentially software for the humans to observe the system and what it's doing. So let's get into it. Let me show you what this looks like. So again, this is all staging data, so it's all fake, but you can imagine the real interactions look a lot like this. This is a visualization of the kind of text message conversation you would have. And in this case, what you're really having, the conversation with is a robot who, in this case, his name is Mira. There's a bunch of different brand names for these bots, talking to the patient after the patient essentially signs up, right? So imagine the patient scanning a QR code and then ending up in a text message conversation. This white stuff is what the patient is saying, free form text, right? There's no buttons to click. This is just them talking. What's happening inside each of these steps is essentially a decision-making process that's based on this blueprint that we're talking about. So you can see here, the first message is canned, right? But then when you go down, right, you've got a rationale behind each of the statements essentially that the robot is making, right? Because they said yes to having medication, but they didn't say what kind, we're going to go to the blueprint to ask them in a medically approved way what pills they have, right? Essentially what, comes next. And this can go on forever, right? There's all sorts of different decisions that are being made by the LLM. One important thing here is the notion of time. So again, a patient is scanning a QR code, we're interacting with them via text message. We don't know anything else about them. And in a medical context, that's really good, right? You don't necessarily want to have provider information unless it's essential. You don't want to have confidential information if you don't need it. So the one thing we need to be able to help to schedule medicine is what time it is. Because what time it is for them will help us figure out what time zone they're in, and then ultimately sort of, time and date messages appropriately. So, again, this flow continues. And what we do is we set up certain things. So we can see here, this is the type of treatment that we're on. This is the patient's local time. So then we schedule things, then, we can go ahead and do that. We can do it in the right time. And, ultimately, you can even get a couple of cases where, if we want to be a little bit vague to the system, it asks us when to take the medicine. We say, I'll take it in a few hours. And it's like, well, the system says, well, I really need to know a more specific time. This is the agent, right? The virtual OA trying to figure out, how to get really crisp, specific times, for the user. It's not explicitly written out that, this flow would have happened and we're sort of laying it all out like this, that this is the LLM making decisions on the fly. And what I can do here is I can also show you, what this looks like essentially inside the agent's thought process. So this is one example, and you can see here on the side, this is basically a conversation with a patient. The messages up here, from Mia are from the agent, and the patients are interleaved. You can see the sender, is where we find that right here. But this conversation essentially goes into every run. So when we kick off a given run of the LLM, we're passing in all of this data. And what we're doing is we're basically letting the agent look at all of this input and then reason about the situation, right? So we're giving it all of this context. We're letting it read. We're letting it read blueprints, right? And so this idea of like a blueprint is really just text. This is a version of what we would call agentic RAG, right? And the idea is that all of these documents are just provided as context that the agent loads dynamically based on what it understands the situation to be. This is all the way down to things like, here's triage, for different kinds of things. If the patient is nauseous, in this case they were, I need to read a specific file that talks about nausea, right? I need to get the time. I need to understand, what time it is for this patient. And then you can get a summary, right, of what's going on here, right? And so you can see, this whole thing, right, is basically the system's analysis of what we believe is going on here, right? And this then leads to decisions, right? And the kinds of decisions that are being made are, I need to send some messages, right? And I'm going to send some messages and I'm going to get the confidence essentially of these messages, right? And so this whole idea is expressed in these blueprints. And so this right here is one of the blueprints that we use, and in this case, the onboarding blueprint. So here's the treatment, right? Here's the medication that, someone is gonna need. And instead of saying, here is the specific flow of all the buttons that need to be pushed, here's the overall structure. And the LLM is really good at figuring out how to jump around. Part of our guidance is don't ask the patient a question that they've already answered. If they told you how many pills they have, don't ask how many pills they have. Just take that and figure out where in the blueprint to drop in, right? And you can see here, like, this is just a Word document, right? This is fundamentally very, very simple stuff. And, as you get further in the treatment, it's still just a Word document. We're able to build these kinds of artifacts and then let the LLM navigate essentially the overall conversation with the patient itself. It is very tightly guided to use this italicized text as the actual words that it delivers, right? And that's because this is medical advice, right? This needs to be very precisely worded. And we have a physician's assistant who actually helps us generate, all of this text. So again, I realize that's a lot. And so I just wanted to make sure I left some time for questions. But to go back over here for a second, what this leads to is, again, a couple of these, sorts of situations where, the human, right, observing this thing has this console, right? So the operations associates, the human operations associates can look in and observe these treatments, right? And to try to help people, if they get stuck. You also have the ability, again, to intercede. And so this is one example of how that looks. So if essentially the system triggers the confidence threshold, the human has an option to approve or give feedback. The client very specifically asked us not to build a console for editing, kind of the entirety of the patient's data. What they wanted, and we 100% agreed with this, was just to give feedback, right? Essentially talk to the agent as a person, right? Talk to the agent as a person and get that feedback, and essentially, just make different decisions, sort of tweak the messaging you're sending, in an agentic way, right? So this made the software very straightforward. There's not a lot of complexity in what we're having to build for the humans to observe it. Okay, so I think, did I cover everything I wanted to get to here? I think I more or less did. So again, this is a very abbreviated version of this much longer talk. So if there's anything here that I should go deeper on, hopefully there's a couple minutes to expand. But this approach really does allow LLMs to make decisions, right? That's the interesting thing about this. Behind almost any workflow, and any software is currently a lot of hard-coded logic, right? This is exactly the way that this thing, has to work because that's what the code says. Now you can give LLMs a blueprint and you can give them tools and they can do kind of whatever is needed, right? And that's a really, really powerful, interesting thing. This also does use MCP. And so part of this is that MCP is a way to reduce the amount of code you have to do to sort of, overall incorporate all this. We were able to build our own little MCP server to really sort of do the back and forth communication between our system components. But between that and the blueprints, there's very little code in this system. I would guess that there's probably as much prompt as there is code, just maybe a few thousand lines of each. And that's really it. And again, you can create really big productivity with these things, right? 10 times or more, right? And the idea of, again, just like, building these things with largely text, helps you go faster, right? There's a lot less involved when you're building, fundamentally just these text-based workflows. You could have done a bunch of this off the shelf. This client was, both very, in the medical space, there's a lot of regulation stuff involved. There's a lot of reasons why off the shelf might not have made sense, but it's also not that hard to build, right? So a lot of what we were doing here was really just to test the limits, of what we can do with this customization. And, again, we needed custom. In this case, I would recommend people just use the best available tools, and you can always change, because really what you're building is kind of the logic on how these systems work and not necessarily the details of how it's all coded. And this is me, if anyone's curious. My GitHub has a couple of examples that are kind of similar to this. This obviously is proprietary client code, but I'm just glad I could show it to you. And this is otherwise where you can find me and various other things like this. So with that, I will pause for questions.
Oh, thank you, Dan. This was great. Like, I had no idea that you could do so much with the so many prompts, and that's amazing. I'll open up for any Q&A. I don't see anything right now there, but let's just give people a few minutes to type in.
Sure. I'll use the moment to take a drink. I'm getting over a cold.
Absolutely. Absolutely. There is one. Yeah, sorry.
Yeah, no, I'm happy to read it. I've got the window over here. So what was the process to create the Word documents? So in this case, we were fortunate in that this software already existed, right? So what we did is we came in with our clients and we said, look, we don't think that the right way to prompt Claude in this case is to provide a picture of your flowchart. We need to come up with some other version of essentially what it is that you guys have built in terms of the logic of how a treatment goes. So what we did is we took the visual blueprints, right? We do still have them. And we basically asked, I think it was some combination of Claude and OpenAI, to make us a markdown version and basically say, look, express the logic in this flow as markdown. And we need to then instruct the agents to essentially use it in a different way than the flowchart was previously used, right? And so in this case, that means, look at this blueprint as guidance to interpret the situations you find, right? Here's how you treat the patient. When patients ask you questions, always answer their questions. Doesn't matter if it's in the blueprint or not. Here's the resources you have. So a lot of it really ended up being kind of a new hire guide for these operations associates. That's essentially what we turned the flowchart into. But it was very much, a combination of us with the client who understands this very well, using AI to generate a file that was logically equivalent to the flowcharts.
Perfect. There's one more. What's the biggest problem AI solved for you, and how would you solve it differently if you were to do it again?
Sure. So in this case, right, the biggest problems for this client were that they were not able to scale the approach, the software, the team that they had built up to that date to new treatments, new clinics, new things like that, right? They knew exactly what it would take to build a team that could service N requests from, a given patient population, right? And I think they were serving, let's say, tens of thousands of people this way. But they had no idea how they would serve hundreds of thousands, right? They did not want to scale the operations team linearly. They didn't think the software really could scale. So what AI allowed them to do was rethink the core logic of how you serve people such that you can do it more flexibly, again, just based off of these different types of documents, and that you could use humans differently, right? If they hadn't been able to use humans differently, even if they'd been able to scale the software, it wouldn't have really solved their problem. So it was a combination of, because the AIs are capable of making the same fundamental decision these humans were, which was, what does this text message say? What should I say next? That is something an AI can do with the appropriate context. So because that was possible, We just changed the relationship of the humans essentially to the software so that they really became more supervisors.
Thank you. There's one more from Jason. Thank you for the wonderful presentation. I believe you said that the chatbot had no knowledge of the patient. Does that mean that for each subsequent session, it does not remember any previous conversation? And if so, have there been any consideration to build in such memory for better patient experience?
Yeah, that's a great question. So the shortest answer is the LLM is always provided at the beginning of, well, let's think about it this way. The LLM is sitting there waiting. A patient texts, right? A text message from a patient is what kicks off the process. What will then happen is that the entire conversation with that patient is sent to the LLM along with the directive, basically of saying, figure out what to do next. That could be set different flags in your state, right? You know, oh, the patient's going to take the medicine at this time. Let's write that down. It could be I got to switch to the other blueprint because they're changing the medicine they're taking. So I got to change the, like any of those things plus generating new text messages are all fair game. And so, you know, the way that the chatbot knows the patient is just through that. It's whatever the previous context is. So the first time the LLM meets a patient, they know nothing, just their name, right? Literally, all I know is your name. I believe you're here to go through this treatment, so I'll ask you about it, right? But all the rest of the knowledge is built up over time. There is a distinction with cases where there is a provider relationship. So there are cases where if you know the provider, if this is being provided by a specific clinic, there will be an integration to more data. But most of the time, it's not relevant, right? You know, you're generally not asking the agent about anything other than the treatment you're on. If you ask something about your medical history, it might just say, "Yeah, I'm sorry, I can't see that," right? Like that's not part of my job. You could imagine that in the future, maybe it would be part of their job, but it's not currently. So we mostly isolate it just by virtue of we try to discover all the information we need about patients rather than depending on it being provided to us.
We have one more. Can you please share the process you use for the LLM selection? Any example where you picked one first but had to switch to another, and why?
Sure. Yeah. So I think in this case, the main reason we picked Claude was a combination of fundamentally the client's comfort with it. You know, and this is a real factor, right? So, you know, people have their opinions about OpenAI and Grok and, you know, Anthropic and Google, you know, as the big ones. And so those opinions matter. There are some more trustworthy companies or companies people are willing to trust more than others. Anthropic has a great reputation on this front. Also, Claude was very, very steerable. Like we'd worked with in the past. So like that was partly our recommendation too, was we think Claude is going to be the easiest to steer. But we wanted, you know, the client to essentially articulate, well, is that okay? Because of course we can make this work with others. It's just a different system and there's going to be different constraints on it. So the main thing, the main other one we did work with was OpenAI. We managed to get a pretty good version of this running with O4 Mini back in the day. I think that model's been superseded now, but like O4 Mini was very good at this. The main reason we didn't love it was that it was hard, and this is a combination of business relationships and technical, it was hard to see its reasoning. So the thing that I showed you in terms of that trace, right, of like how it was thinking, you can't always get an equivalent version of that from the OpenAI models. Sometimes you can, right? I mean, I'm not saying it's impossible. Claude, though, has a very specific way to do it, and it historically, in our case, has just been more steerable and more transparent.
Yeah, I think I don't see any other questions unless we'll give 7 more seconds if somebody types in. Otherwise, I'll call it. All right, I think that's it. Dan, thank you so much for your time. This was great. You can continue attending the conference as a participant. Yeah, thank you so much for your time.
Right. No, thank you, guys.
Thank you. And I see we have our next speaker as well. So I will quickly introduce him. And from Amazon to F5 to Milliman, he led enterprise-wide digital transformation across retail, healthcare, technologies. As CIO at Milliman, he drives AI adoption while keeping people's first. Welcome, the leader, Hitesh.
Thank you, Sangeeta. Good to see you again.
To see you again.
Hi, everyone. I'm excited to be here. I'm sure you guys are having a good time the last couple of days. There have been a lot of good sessions and a lot of good conversations. So I'm going to start sharing. I know a couple minutes early. Is that okay, Sangeeta?
Yes, go ahead, go for it.
Great.
Yeah, that looks good. I can see your slide there.
Sounds good. Hi, my name is Hitesh Sachin. I'm the CIO for Milliman. Milliman works in the space of risk and insurance. And prior to that, like Sangeeta mentioned, I've been in the technology, retail, healthcare, energy sector. And throughout all of that, the common theme sort of has been transformations. Organizations want to go from one point to another. So how do they leverage the right skill sets, and how do they actually go from the current state to the future state? So that's sort of been common across. But as I describe some of my career journey, I sort of start to feel old because of the things that I've done in the past. Part of it is true, but I think other part also is how things are changing so fast all around us. So I often feel, and a lot of us feel, sort of left behind and always trying to catch up. And I think generative AI is one of those things where things are happening really fast. So in the next few slides, what I'll try to do is try to share what's happening around us and what can we do to actually participate in it, and not just effectively participate, but also at the same time lead. So like AI is here and it is transformational, right? So we've been seeing it all over the place. And even before the Chat GPT was, the term became popular, Wikipedia described GPT. One of the definitions in Wikipedia for GPT was general purpose technologies. And the way it described general purpose technologies is a technology that has affected an entire economy and it has drastically altered societies. It's got a lot of spillover effect. So some of those GPTs are like money, printing, steam engine, electricity, computers. They're embedded in everything we do, and it has drastically changed how we work and how we interact and how we think and how society as a whole sort of develops. And so I believe generative AI is the next GPT, which is a general purpose technology, because it is embedded everywhere and it's going to change how we act and how we react to everything that's happening around us. So also, if you look at adoption of these technologies, and it shows some technologies over the last 75 years where adoption curve over time has increased a lot. It has become a lot steeper. So like in recently it's looking at like smartphone, social media, tablet. So if you look at Netflix, it took Netflix more than 10 years to get to 100 million customers touch points. For Instagram, it took 2.5 years to get to 100 million. TikTok got there in 9 months. And for ChatGPT, it just took 2 months to get to 100 million. So you can see how fast these things are happening, and they got to 1 million in like 5 days. So the pace of change of technology is increasing and accelerating really fast. And we have a lot of examples also, but there is something called Amara's Law. So Amara's Law says that we often overestimate the impact of technology in the short run, but underestimate the impact in the long run. So what that means is that the initial excitement and hype sort of leads to inflated expectations. And we don't get all that from the immediate impact. But true transformative impact often comes until much later. But I think with the speed of generative AI, we are starting to see some of those transformative changes also, and transformative impacts also that are happening. So if you consider, say, healthcare has already been using like early detection of health risk using patient data. And even in one of the sessions from data to decisions, that talks about like how we are making real decisions that are impacting people, which we couldn't have done in the past. Similarly, if you look at insurance, so the automated risk assessment and the processes are making it a lot more easier for customers and improving the customer experience itself. And on the flip side, for the insurers, the people who are actually insuring, it's helping them create newer and more powerful and more sensitive stochastic models to be able to assess the risk, probability of the risk, and what is the cost of like ensuring that risk. And stochastic models they sort of use probability to forecast outcomes in a complex ecosystem where we have like a randomness and uncertainty plays a big role. So it becomes critical to be able to take as many variables as possible due to that randomness and be able to change as and when things are happening and things are adopting. So all those things are real examples. They are here right now. But what's common across all of these is that it's not just the AI is delivering these things. It's humans are leveraging AI to deliver these better outcomes. So if you look at like, it's not just a matter of what, it's the diligence and the work that it takes to validate what's being done. How do you iterate over it? How do you make sure that it's working? Like we've had AI for a long time, like for the last 10, 15, 20 years, decision systems have been there for using AI, but generative AI is the one who's changing the game, who's changing how we interface with the AI. So, and this is like one picture that I love where the leftmost box describes things that humans do today. And then the second box talks about things AI will do, which is within the scope of humans do today. So AI will help us what we already do, and it'll help us do little things, some things more than that and beyond that. But there's a whole new box of things which we will do with AI that we're not able to do today, or we were not able to do. And that's how some of the ways businesses are also looking at. So productivity enhancement and efficiencies are one part of it. But the other part of it is like, how do we enable newer businesses, newer markets, newer products, which we were not able to do earlier, but we can do now. So the limiting factor here sort of becomes the imagination of what we can think of. So I have two teenage boys, and they constantly keep me challenged, and they constantly are telling me how to use it, different ways of using it. So like few months ago, and most of us have plants which die in the house. So what he did was, one of my son, he just took a picture of the plant and he said like, what should I do? AI was able to look at what the plant was. It was able to create few scenarios that could have happened, either like too much water, too much sunlight, or pest, or something like that. So it didn't exactly tell me what's wrong, what to do, but it actually gave me a lot of ideas, and which I could relate with the things that I can observe to figure out and to do things. Otherwise, all of these things would have taken me months, like weeks and days of time and the diligence to get it done. In this way, within like few minutes, we were able to actually figure out and fix the problems. And so our imagination sort of becomes the limiting factor here. And like another example is like we have healthcare insurance and auto insurance or home insurance. It's difficult to understand those policies. We upload two policies into it, and it tells us like what are the commonalities, what are the differences given our situation, what's important, what's not important. So it's able to do all of that analysis for us, but it's not going to decide all those things for it, right? So what becomes important in all of that is, as it does all this analysis, the important part is the critical thinking. So that's become the like a main ingredient of how we actually use and leverage what AI as a tool is giving us. So in order to define critical thinking is, in simple words, I would say, it's not accepting the AI output as is, but asking the questions before we take actions on any of the output that's happening. So it's bad data in and bad decisions out. And you've probably read about a lot of these things in the past. And if you take example of, say, recruiting, in the past, some of the recruitment tools might screen out qualified women and minority candidates because the tool was trained on only past male dominated data. So that can have an impact. So without actual critical review of that, the bias sort of becomes systematic. We just add to that bias. Similarly, in healthcare, what could happen is also that an algorithm can flag a patient as a low risk because it correlated healthcare spending with good health, leaving out the data that not everybody would be able to afford the healthcare and the healthcare cost. So that sort of becomes the bias and reinforcing the wrong learnings. And at that point of time, critical thinking and the policies need to act then to be able to correct and adjust to it. And that's why you see a lot of regulations are coming in, because I think there was a news article like a year or 2 years ago where it takes less than a second to deny a claim. So how do we make sure that we are using technology at the right level where it helps us, not starts to hurt us? So, and then also like AI helps us analyze data better, right? And it'll help detect patterns that might be invisible to humans. But it cannot be a substitute for human judgment. Because if we leave it unchecked, it'll amplify errors, it'll reinforce the bias, and it'll lead to a lot of false confidence in the results. And it sort of becomes self-fulfilling prophecy, because that's what it sees, that's what it learns from, and that's what it suggests then. So what can we do to make sure that we're not letting it happen, right? So few simple things you could do is looking at, are we solving the right problem, right? So simple 3-question framework, are we solving the right problem? And what might be not included in the data? Like, what are we excluding from the data, which is resulting in that particular answer from AI? Or what can go wrong if we were to act on this output, right? So what unintended consequences that happen? So all of those things are for us to ask, right? And like AI can give us answers, but only critical thinking can tell us whether those answers make sense, if they are fair, and if they drive the right outcome you actually want. So, and that's where like what our role now becomes is to provide that critical thinking. And we often talk about like, hey, in the future or the AI future, I think we are in the future right now. This is the future. And present is the future. And I think oftentimes like generative AI is so captivating and addictive that you sort of get lost into what you really wanted from it in the first place. Like, I'll just give another example. Like a couple days ago, I don't know how many of us have seen when we're trying to connect and browse the internet when we're offline, Google has a game which runs in offline mode, Dino Run or a T-Rex. So when you're offline, you can still play that. And 2 days ago, like my 12-year-old, he just gave a ChatGPT prompt, hey, I want to create a game like T-Rex, write the code. It wrote the code. We were able to run it. Within 2 or 3 prompts, he changed that whole thing to make it like a Super Mario game where he said there are coins and there are lava holes and there are other things. So we were sitting there to solve a different problem, but like we just got into this captivating, addictive part of what's possible. And we just got lost into that. And we ended up spending an hour on actually just trying to work through all those things while we were not there to do that. So it is fun, but I think you can sort of start to get lost into what you really need it for or what you want it for. And I think that's why defining the problem is critical. Knowing what you want, what is the problem you're solving, or what opportunity you're trying to explore. And that's why AI will provide a lot of viewpoints. So it's also important to actually be open to those viewpoints. So knowing what matters most is important. And then probe everything, ask the right questions. Like AI knows everything that's out there, but it doesn't know your context very well. AI will always have an answer for you, right? So no matter what you ask, there's always an answer for you. So question everything. And oftentimes, like when I'm talking to people and within my team or elsewhere, they'll say, I don't know how to get started, right? So I say, go tell it, this is what I do. How can I use you better? Or if you don't even know, like, oh, what are the questions that I'm not asking I should be asking? It's not that it's going to give you everything, but it's going to start to provide you thought process into what else you can look at, what to consider, what not to consider. And so that becomes important. And then at the end of the day, responsibility of AI and AI outcomes lies with us. We don't have like, so right now, if something goes wrong, you can go after an organization, and you can sue an organization. But at the end of the day, if someone's using AI, you cannot sue AI. Organization and people are still accountable for it. I mean, we're not there yet. Some people are talking about general intelligence and all of that, but not going into that vertical. Responsibility lies with us. We've already talked about like bias, how it can become systematic and how we can add to the bias. And the second part of that is security, right? How do we build and use this in a secure manner? Like, how do we build the guardrails so that we can protect it against the attacks from, like, say, prompt injection? Are we building defensive mechanisms? Are we grounding it? So all of those things become very critical as well. And the third part of that, I would say, is environmentally sustainable. So it's not just a matter of accuracy. It's also the carbon costs. It's also the maintenance. It's also the sustainable aspects of it. So all of that responsibility lies with us. So we need to be clear about that. We need to know how we're using, what is the value it's adding, and what's the cost of that. So I think in all these things happening around us, so many different ways of using AI, so many problems, opportunities out there, we sort of forget the human side of it, right? So AI is maturing really fast and changing really fast. And I mean, I cannot change that fast. Most humans cannot change that fast. And so with everything that's happening around us, like technology is changing so fast, how do we keep up? And there was a study which said there are 300 new languages and frameworks that were introduced in the last 12 months. So how are we able to shift our perspectives and assess relevance and keep that mental agility to be able to react to this fast changing technology all around us? And we have seen these failures. Failures are a matter of when, not if. Every major tech company has had failures, and 70% of those are due to human errors. So they'll always happen. They'll always happen. And I think what AI is doing is not just failures, but also unintended consequences. Because it spreads too fast, impact is too huge. That's why a lot of regulations are developing. So how are we able to anticipate, mitigate some of those things? How do we simulate crisis so that we don't have all of these unintended consequences happening because of the use of AI? And burnout is real, right? So with everything happening so fast, leads to exhaustion. Exhaustion leads to complexities. And 80% of cybersecurity breaches that are happening, they're caused by human error. So handling crisis then requires clear and structured approach. Like, how do we know where the issues are? How do we evaluate the options? How do we prioritize? How do we act swiftly so that we are not burning out? We are also actually prioritizing on the right aspects that need to be focused on. And last but not the least, career longevity. So what's relevant today is obsolete tomorrow. I was reading somewhere half-life of a technical skill is less than 3 years. So a lot of things that we learn today in 10 years, a big part of that is going to all change. So how do we stay curious? How do we constantly upscale and rescale everything that's happening? And how do we focus on our well-being, not just mental, but physical well-being also? So this sort of becomes critical because we are in the middle of it. So we need to take care of ourselves, and everybody needs a different way of doing those aspects. So, and I think so, my message is stay curious, stay adaptable, stay resilient. And this is actually my last slide. And so what it talks about is AI is here, right? But we are the ones who are shaping the future of technology. We're not just watching it happen. We're not just reacting to it. We are building it, right? So AI is no longer a distant promise. It's here. But the future isn't written by algorithms. It's shaped by the questions we ask, the resilience we build, and the mindset of being a student for life. I mean, I believe in it. be curious, stay critical, lead with confidence because you are the future. So I wanted to just bring some context around how things are happening around us. It's a fast changing world, and how can we keep our sanity, and how can we play a pivotal part in it? Because oftentimes we think like, oh, we're the only one and everyone else knows it, but everybody around us are in the same boat. They're all trying to figure it out. So let's help each other and lead this work. So Sangeeta, that was my time, and I want to leave some time for questions or discussions and stuff.
Absolutely. This was an amazing presentation, right?
Thank you.
All right, we'll open up for any questions that the attendees have. Feel free to type it in or raise your hand. We'll unmute you. There's a lot to ponder on what you spoke, like to think through. Yeah.
We get involved in the day-to-day thing, so often we
We
don't
forget
take
about the,
time.
yeah.
We're
Yes.
humans. We need time.
Okay, we have one question. Have you seen any application of AI in climate change risk modeling as applied to insurance?
Yes. So, like even Milliman has authored a lot of papers in terms of climate change and how. So, the whole part of insurance is like how to quantify risk, how to get the probability of risk happening, how to cost a risk. So you can say, how much do I need to save to accommodate for if the risk happens, right? So what we're also doing is like we're working with United Nations Development Program. So right now, these capabilities are only in some of the developed countries. So what we're working with United Nations Development Program is to create this risk analysis and actuarial skill set in countries in like Asia or in Africa to be able to model these events that can happen within a country, whether it's related to climate change or whether it's related to corruptions or whether it's related to economic conditions or wars that are happening around us. How do you assess the likelihood of it? How do you assess the impact of it? So I cannot get into the specifics of like how some of the things might cost and change or impact. But yes, there's a lot of work being done. And if people are interested, I can share some of those links with you, Sangeeta, and you can share with the broader people. Yeah.
Sure, yeah, absolutely. Any other question? Let's just give them a few minutes to digest what you went through. It was very
I
nice.
think I
Yeah.
solved all the problems, right?
Yes, there are no questions. Everyone is like, great, great, great. Yeah, it was a great talk. Right.
And my contact information is there if you want to reach out for anything, if you just want to talk about some things. If you want me to come and talk, I'm
We
happy
have
to.
a happy hour at like another. I don't know if you're staying for the next session. I the speaker was supposed to speak a little bit earlier, but we had to reschedule based on his availability.
Okay.
I'm very looking forward to his session. It's like building your own Iron Man suit. So I want to see what the talk is going to be about. Very excited about it. So stay for that. Okay, we
I
have a
want
question.
that suit.
Exactly, that's what I'm saying. We have a question from Jason. How can we ensure AI will be helping us improve our standard of living and not just give us more stress?
So I think the onus falls on us, right? Because we cannot rely that AI will be used in improving our standard of living. Because as we see growth of any technology, we also see the growth of threat actors who are trying to leverage that technology. And we've seen a lot of that recently in the cyber risk, right? Even in mimicking fake emails, phishing, all of that stuff, they're getting really professional, right? So there is that part of it. But oftentimes, asking those questions to provide, like, what does it mean, our standard of living, right? So I think if you look at it, how much time I've spent on a daily basis, like 5 years ago, on specific tasks which are really mundane, I'm spending a lot less time on that. But the flip side of that also is that where people are saying AI is doing a lot of creative work, writing, movie making, but AI is not doing my dishes and laundry. I want AI to do dishes and laundry so I can do the creative work, right? So I think we cannot just assume and think it's going to improve. We have to figure out what is the right way to use it, what works for us and what doesn't work for us. And like there was a talk, I was in a conference and somebody was talking about, and they presented a pretty grim picture of it that, hey, everyone who works with computer, all your jobs are going to get taken away. What's going to come back to is be an electrician, be a plumber, but that's not the case, right? So, and as some of these general purpose technologies have come in, it's not that that work has gone away. The work has shifted to higher level. And I think that's where critical thinking becomes important. And I do think like in schools, we are saying don't use all these tools and Gen AI and chat GPTs. What needs to happen is to evolve the curriculum in the school so they can leverage it better. They can apply their own critical thinking. Like you can say, I have these 5 ingredients in my fridge. What should I cook? You can get some ideas, but you want to use your own creativity. Like, what do you want? How do you want it? What taste do you want? So we have to make sure, as and when we're using AI, we're not giving it the power of taking away critical thinking from us and thinking on our behalf. So I don't know. It's not a straightforward answer.
No, this
But
points me to your slide that you shared, right? You had humans, AI, and then what humans can do with AI. So,
yeah,
that's what it is. All right. No, thank you so much. I don't see any other questions coming in. So you're more than welcome to stay for the next session. And we have a happy hour. So link is different. Join us there. All the attendees would be joining us and to have some interaction. But thank you so much for your
Thank you for
time.
inviting me. It was great fun. Yeah. Take care.
Thank you. Hi everyone, we still have like 4 or 5 minutes before our next speaker comes in. So if you want to take this break, because the next session is going to be about an hour and a half long, it's actually a workshop, very interactive. He wants you to interrupt him with any question that you have and things like that. So take this last 4 or 5 minutes to grab a snack or a water or whatever you need. Yeah. So next, Gary, we have another speaker who's going to, there's a workshop he's going to do for an hour and a half. And then there's a different Zoom meeting link that I had sent to everyone, which is a happy hour where, we all can interact with each other and share some our ideas and thoughts on what our takeaways are from this conference. I hope I've answered your question. Hello, Xavier. Yeah,
Thank
all right.
Doing.
Right here. Let me just quickly introduce you and then you can get started.
Sure.
I will keep an eye on the question and answer and anyone raising hand for wanting to ask a question because you wanted it to be an interactive session, right?
Oh yeah, absolutely.
Okay, perfect. Okay. All right, across industry AI builder and team leader Xavier turns LLM into real measurable outcomes fast and responsibly. Today he will share the blueprint for augmenting your capabilities with AI. Please welcome Xavier P. Hansen. All yours.
How's everybody doing? Is that my friend Kyle in there? I think it is. Mr. Speed.
Yes. Yes, Kyle is in there. Yes, Mittal is also there.
Outstanding. So I'll be sharing the deck in just a moment. I wanted to first couple of intro points that are key. Very thrilled to be here. It's a pleasure to participate in what looks like a really fantastic event that Sangeeta has put together. I am thrilled to join. I am here on a personal appearance, and so just want to make clear that nothing that I will share or discuss here in any way represents the views or the positions of my employer, and that this is work that I'm actually pursuing with a number of other explorers of innovation and generative AI. And so in the presentation today, I'm going to end up doing a few things that may be different than prior presentations, with a number of co-authors, which are really close collaborators that I've had over the years on different teams and different types of work. We wrote a paper that we released and uploaded to the CERN website, Zenodo. I'll put the link in the chat before I leave. I'm not going to cover that paper today, although I'll bring 2 or 3 concepts from there that I think are going to be helpful. Happy to discuss that paper further. People can find me on LinkedIn very easily. There's not a lot of Xavier Hansens. There's just one more guy who works for a bank in Luxembourg. That's pretty much it. And so what I wanted to do today is that in order to really make, this is again a perspective that I've had, building in the innovation space with generative AI and LLMs in particular, is that having a good understanding of what LLMs represent and how they work, and an overview of what is taking place across many different spaces using large language models is actually really helpful before we get into the second piece of the conversation today, where we start to look at different prompting techniques and different forms of prompting. And I think that that's going to be a really helpful framework for everyone to work with and to think through, potentially to be able to contextualize a lot of what you've heard during the conversation at the summit over the last couple of days. So I'll start sharing the deck. And part of the, without impugning anything, any part of my talk to Nassim Taleb, I do want to certainly say that a lot of my thinking has been tremendously influenced by Nassim, and that let me just, there we go. There is the Zoom. And so just in a funny way, the deck that I'm sharing is going to be very bare bones, which is very much a Nassim Taleb trademark. He actually just has a chalkboard for his videos. But really the focus is we really want to focus on the ideas, right? So and yes, I used Claude to build this deck, but I don't have the version of Claude that yet does the PowerPoint. Supposedly it's actually quite good. So for those folks who use a lot of PowerPoint, it's only available for the Pro Ultra users. So that's a little steep for me right now, but it's supposedly coming to all Pro Plus users soon. And it's supposed to be, they're supposed to be the one who have really cracked the PowerPoint piece, because so far other attempts have not been so successful. But in any case, the name of the paper is The Kaleidoscope of Knowledge and the Iron Man Suit. And we'll discuss a little bit about these concepts later on. But the first thing I want to start with, and let's make sure that we actually have this working. Here we go. So we're going to get a couple of baselines. And again, Sangeeta is monitoring the chat, right? So if there are folks who come and have questions, I much prefer this to be interactive. You know,
they can unmute and they can ask any question they want.
Perfect. That's totally fantastic, because the key thing is for us to make this you know, real actionable and useful and you know, information for the participants, right? This is not about me, you know, recording a lecture. So number one, not all models are equal, right? So one story I like to tell is, you know, you're constantly seeing these days, you know, lawyer gets busted by judge because he had made up cases from ChatGPT, right? And I would tell you this story, right? When I read that, what I read is, you know, Florida man arrested by police for driving 8 miles an hour on the highway, thought he was in a Ferrari, but was driving a Yugo, right? So if anyone is trying to do legal research on, you know, the freemium version of ChatGPT, well, they deserve what they get, right? I mean, like, this just for professional purposes, that is a silly thing to do. If you're doing deep research on Gemini Pro 2.5, or if you're doing advanced searches for papers, for example, scientific papers, mathematical papers, philosophy papers, and you use ChatGPT Pro with web, it's very powerful, and you really have to push the model into very esoteric directions with no guardrails to get one hallucination. I mean, I consistently get fantastic results. By the way, they always provide you with the link too. So, you know, one of the things that, you know, about due diligence, you can just click the link to make sure that the paper actually is what it says. But so it's really important to understand that, you know, so much of the ideas that people have of large language models is that they started to play with it when it first showed up. And so they used, you know, GPT 3.5, or they used, you know, GPT-4. And, you know, the latest versions of the models are vastly more competent and performant. And not just because of the models themselves, but actually because of the frameworks that they've built around those models, right? And the agentic capabilities they've given to them. And we'll talk about what those are. But so I will just say that, you know, what we'll discuss that in the upcoming slides, but you have to pick the right tools to do the job, right? And it will make a big difference. The second thing, of course, is that not all prompting is equal, right? And we will discuss that later on and start looking at some different techniques. But yes, you know, you can do lazy prompting, and I do all the time. I don't always have to, you know, put in an entire context framework. If, for example, I'm doing something very simple, which is one of my favorite things to do, if I find out that, you know, I just ran out of a key ingredient to make my favorite cocktail, I can take just a picture of everything I've got in my liquor cabinet, and I can go to ChatGPT and say, hey, what can I make that's good with this? And I say, give me 5 different suggestions, and at least one of them is actually a pretty darn good recipe, right? Because they have assembled, you know, through a lot of ingesting of bartending manuals, a whole lot of different recipes, and they provide you good instructions on how to do it. So for that, I don't need to do anything else. But if I'm really working on, for example, when I was doing revisions of our paper, yeah, I have, you know, prompts that sometimes are 4 or 5 paragraphs long because I'm investing that upfront time to provide the critical context that will deliver a much more competent response. So learning how to prompt, experimenting with prompting, and knowing what type of prompting you need to use is very very useful. So even among the high performing models, you're going to have different performance, right? So it's not just a question that the freemium version of ChatGPT 5 is nowhere near as good as the pro version. But it's also that, you know, Gemini and Claude and ChatGPT all have a baseline that's similar in terms of, if you look, for example, the type of training they underwent and the size of the models and the type of system prompts that they have to give them guardrails. But Google Gemini Deep Research is uniquely capable from the standpoint of creating really substantial and progressive in the sense of you know, taking you through steps by step, right? The original meaning of the word, reports, right, on complex topics. Claude has always had a fantastic reputation, deservedly, for being one of the better writers, right? So if you're really trying to, you know, put together initial drafts, you know, Claude is quite strong for this. And then ChatGPT 5 Deep Thinking right now is a very powerful problem solver for deconstruction of more complex problems. The same is also true that not only do you have to choose the right models, but you have to also consider, you know, for the purpose of your particular focus, there are all types of frameworks and scaffolds and specialized LLM functions, right? So if you're coding, I mean, I'm sure here anybody who's looked at it already knows that Claude Code and Codex, you know, are pretty powerful. You also have Perplexity that just released the Comet browser, right, which is an agentic browser. It was just in the last 48 hours they made it available to everyone. It was before by invitation, and you can do some pretty nifty things with the Comet browser. You know, the more agency you give it, it will go through all your emails, summarize everything, but you can also tell it and give it the capability to search for products for you according to a set of criteria, compare prices, and actually make the purchase. Right now, I will repeat throughout the conversation that my recommendation is, if you're doing that, have a separate machine, only put one credit card in it. Don't open up your bank information to any of those systems quite yet, because you know, there are tail risks involved there that you don't want to take, right? You don't want to take the one chance in 1,000 that somebody empties your bank account. That's not worth it, right? But experimenting with it is certainly very interesting, right? RepoPrompt, a fantastic coding framework. There are others, of course. Replit is now very popular, and OpenAI bought Windsurf. But I would recommend people take a look at RepoPrompt. It's an interesting solo effort that's getting a lot of attention lately. And then DSPy is a very interested automated prompt optimizer. And it's what its founder really describes as an LLM programming framework. So it's basically providing you with a set of categories to think of programming the LLM, right? So you're basically, you're not thinking of it as simply doing a text prompt, but instead thinking of it as structuring the response of the LLM as a program. And they have a looping process by which it will automatically follow a set of examples you give it, a set of criteria you give it to measure whether the prompt is better or not. And once you give it that, it will just iterate until your prompt meets the optimal value in your criteria, right? It's a considerable amount of upfront effort, both to learn how to use DSPy, although they're getting much better at at making it seamless. There's a lot of excellent tutorials out there. And it's also a lot of work. But if you have a complex problem with substantial ROI, well, best practice with or without an LLM is that you should think about your problem and you should deconstruct it, and you should know, well, what are examples of success? How do I measure success, right? Those are actually just pretty sound scientific principles. So again, think about what models you're going to need, think about what functions or what frameworks are available out there. And what's wonderful is that you don't even need this slide, although I'll be happy to share this after the conversation, because one of the things that I'm going to talk to you about is that you can just go ask ChatGPT 5 or Gemini or Claude, hey, what are the current frameworks and scaffolds for LLMs? Or, hey, compare all the SOTA models that are out, state-of-the-art models that are out there, and tell me which one is good at what, right? And this is where it's going to be key for us to really understand what a new type of technology we're dealing with, right? So that brings us to baseline 2. What is an LLM? LLM is just and again, we're not going to get into the technicals of deep neural nets and the transformer architecture. Fascinating topics, but they're not necessary for the conversation we're having today. But it predicts the next words from patterns in data, right? And that enables it to not just be, as we'll discuss later, an excellent translator, or as I like to call it, a two-way explainer. But it also can take language-based instructions and follow those instructions, and again, increasingly with a large degree of accuracy. Now, in the paper that we wrote, we actually, in the very title, introduced the notion that it's a misnomer to think of large language models as large language models, because they're actually not just trained on language. They're trained on knowledge, right? And whereas language is unstructured data, as they call it, we make the case that knowledge, human knowledge, if you're talking scientific articles, philosophical treatises, religious texts, and so forth, are extremely sophisticated and structured data set. As a matter of fact, we would raise it's the most advanced data set that we're aware of in the universe. It's the product of all the human brains for the last several thousands of years who have written it down. Now, the LLMs have ingested all of that, right? It's a lossy compression, but it is a pretty significant new development. And I actually posted on LinkedIn earlier today that you can imagine if you manage to build the largest, gigantic physical library where you could store every single book that's been written. If you're going to that library, the knowledge is still separated by the book covers. Now, the advantage is you're human, so we assume, everybody on this call, we don't yet have AI avatars. So you have cognition, you have continuous learning, and you have continuous memory. And those three things the LLM does not have. Some folks can argue that they do, but right now I will challenge that we do not have any concrete evidence that they do. And so what you can do in this ginormous library is that you can pick a book and then pick another book and then pick another book and read them and start thinking and make connections in your head. And then if you're really a researcher, you may also think, I could go explore a section of the library where not a lot of people go, but that might be relevant to this. See if I discover something new. And then if you have taste, as they call it, as a researcher, you'll start thinking, what's missing from these books, right? Isn't there something else that we could be thinking of? And then you're going to be exploring new ideas, new categories of ideas, anything from, the best and most fantastic example we can provide there is Einstein's paper on relativity, right? Most intense, knowledge-dense, impactful paper that an LLM would not produce, right? Because the LLMs are very good at exploiting what we already know, all the data they've ingested. They're not so good at exploring new categories of ideas. That's the role of humans. However, in the LLM, all the books, there are no more book covers. all of the knowledge is in one giant multi-dimensional network. And each subword, each node has weights and parameters that map out the connections that it has to other words. And you can start really thinking in your mind, well, how many different ways can we say the word consciousness in different contexts, right? And we can take simple, silly examples, right? Take the word bank, right? There is a bank, but you can also bank on something, or you can go to a river bank, right? So that's just providing a really basic example of what we're talking about here. But if you're starting to think about the different context that every word and every concept can be used in, all of that is somehow mapped out in these large language models, in this giant network. Unfortunately, or fortunately, it's a black box because there's way too many parameters and way too many paths that can be taken for us to actually track every answer. And so really we input, we have a mechanistic interpretability, which is the nascent field that's trying to study little pieces of the large models to understand how they activate and how they work. And they've discovered a few things, but Dario Amodei of Anthropic himself was recorded this year in an interesting paper that he put out that we have no idea how these things work. We don't. So it's more, it's a case there of really thinking about that it's a probabilistic combinatorial engine because we can't see inside of it, and we can only use levers outside through prompting, through curating the training set. On the other side, to reinforcement learning and human feedback training based on the outputs. We call it a kaleidoscope, and where you have the kaleidoscope of knowledge, right? But it is really important to start thinking of that, right? That it's not just language. It's not just trained on people talking. It's trained on all our knowledge. And if you want to test it out, you can go to ChatGPT Pro right now and say, only use primary sources. Now you are Immanuel Kant, and then have a conversation with the philosopher. And for example, talk to the philosopher about the concept of space and time and how humans would perceive space and time differently than a large language model. And then you will really realize, wow, this core knowledge is in there somewhere, because the response you get is remarkably sophisticated. So the system prompts, what are they and why are they important? So the models have been trained on the internet. And I'm not going to surprise anybody here if I tell you, if you take all of the internet and you compress it into one avatar, that is going to be the most obnoxious troll you have ever met in your life, because there's just a whole lot of awful anonymous comment back and forth on the internet. And if you listen to Sarah Hooker of Cohere Labs, really interesting thought leader in the space, she will tell you that one of the biggest thing that the major AI labs do is to try to take that avatar, which is would be your raw voice, like the raw voice of, remember when we had Sydney from Microsoft that freaked people out, or the original LLMs that they were testing internally in DeepMind at Google, and that they were scared to release, which is what allowed OpenAI to steal their lunch. They shift to the one area, right? They provide these very strong guardrails and system prompt instructions to prevent it from being an incredibly offensive and fundamentally not the most interesting answer that there is. However, problem with that is that we don't know what the system prompts do to the performance of the model as a whole, whether it's ends up causing a loss of the knowledge function of it, right? It's one of the things that we argue in our paper, is that raw models should be available, just don't make them chatbots, right? Create a service where you offer raw model ability for people to do API calls for specific problem solves, and just don't release them into the wild as as a consumer tool. We all hear a lot about agents these days, right? So to demystify, there is no such thing as an agent, right? What an agent is an LLM with a specialized set of instructions that is given access to a number of tools to perform actions that the LLM itself doesn't, have within its own deep neural net, like searching the web, doing math calculation. And you can give that set of instructions can also get it to have defined objectives, and to iterate and communicate also potentially with other agents in a multi-agent system. But again, it's still the same key functionality, right? And as I mentioned earlier, key thing to remember for baseline 2, I'm presenting to you all of this information at a very basic level. But you can go and ask whatever LLM you're using. If you have questions, you can ask me, but you can just go ask the LLM and you'll actually get really good answers. And thinking conversationally with the LLM, like iterating, asking, okay, let me give you a follow-up. Okay, no, but what about this? You said this, but have you considered that? Now, there is an element there too, by the way, to understand that the LLMs in their system prompts are also told to be, super nice to the user, right? And that can lead to a degree of sycophancy that where that can be a problem, because the LLM will just, always tell you that you have the most brilliant idea, whereas that might not always be the case. So I've used a couple of tricks on that too, is that I think that most of the system prompts are based on the idea that that's how they answer when they think it's your idea or your work. So when I was trying to get, real ruthless criticism of our paper draft to make sure that it was good, I printed it badly formatted in a PDF, and I would go to the LLM and it says, hey, I just found this thing on the internet. Can you assess? Like, is it any good? And I can promise you that for our first draft, I got the most brutal critique from Gemini 2.5. And as if that wasn't good enough, I was like, well, maybe ChatGPT 5 will be nicer. And GPT 5 slapped me just as hard. But what they did in that process was to give me tons of new papers to go and remedy the weaknesses of the original draft, opened up several other disciplines for me to go and learn from. And that process was actually very successful, right? So again, I'm not saying that this is a foolproof method, but I'm saying that you need to keep it in mind, right? Think, what has this LLM been instructed to do when I communicate with it? If you have a hunch that what you're getting back is not what you're looking for, keep messing with it, right? Keep finding different approaches and techniques and share those. Talk to other people who are using the models, right? And share these tips within your circles to try to get that the optimal performance. So I love the feedback that we're getting so far. At least it appears we're entertaining, so that's a good start. But I was going to do a first check, because we're at the first 30 minutes, and I wanted to make sure that this is still a good direction, interesting, whether anyone wants to bring up any other topics or whether we're just good to move forward. Cool. Baseline 3, look past the doom and the hype and experiment. Be aware that most of the news you get about large language models is inaccurate. Now, as our friend Kyle will tell you, most of the news you get about finance is also inaccurate. Most of the news you get about so many things are inaccurate. As a matter of fact, you'll find out more and more that if you're an expert in a field, you'll all of a sudden notice how inaccurate the news is. And that probably tells you that you're being bamboozled in the fields that you're not a specialist in, which is one of the reasons why LLMs are actually quite useful, because they can help fill that gap. We'll talk about that. But a couple of things that are key there. Super intelligence is not here. It's not here. And there's a big debate on whether or not the transformer architecture will be a component of it. There is less and less of a debate that it could ever become it because of the nature of this architecture. But it's not here now. That doesn't mean that LLMs are making no money and they're useless. That's also completely untrue. And that MIT study that went out that everybody loves to cite, I mean, like, who would have thought that MIT was going to become like #1 clickbait agent? But that's that study that says, oh, 95% of pilots are failing. Well, the first thing to know is that that's why they're called pilots. It has nothing to do with AI. Pilots fail all the time. That's the whole purpose of having pilots. So that's #1. But on top of it, it's just completely untrue. That study was shoddily put together and people jump on it. Now, I can tell you that one of the reasons why we don't have such good information on this is that a lot of companies are starting to leverage those LLMs and it's starting to really make a difference for them. And they don't want others to know because everybody is competing and there are proprietary methods that are being developed and nobody knows what is patentable or what is not patentable. But I work in industry and I have a number of collaborators who work in other industries, and there are substantial programs that are bringing about massive savings or new opportunities and streamlining across many companies. So don't believe the doom, don't believe the hype. The best way to go about it is experiment and hang out with other people who experiment and find out what they're working on. Next, for anybody here who's coming and to this AI summit and has concrete tasks that they would like to accomplish, or concrete tasks that they wish they didn't have to do anymore, or you want to force multiply the capabilities of your business, or you want to create a new business, et cetera, et cetera. I'm not going to discuss extensively each of those use cases. Happy if anybody wants to follow up with me. As I said, I'm easy to find. But I will say this: don't reinvent the wheel, right? So unless what you're working on is highly, highly custom, where you're going to be working, let's say, on a very unique option strategy. Not that I would know anyone on this call who would do that, but if you were going to do that, probably there's not a model that's another solution that's already out there, because really it's your own brilliant idea. And so to some degree, you're going to have to start tinkering with some of the core tools and models from the perspective of what we discussed earlier. But there are a lot of, I'll give you the example of the attorneys, right? There was a company called CaseNext, super interesting interview to listen to, by the way. I'll try to find it and put it in the chat, but you can find it on YouTube. They were talking to the YC Combinator crowd about a year and a half ago, and those guys started to work with OpenAI as early as ChatGPT 3, and they were one of the partner companies that were working on concrete use cases. And they were one of the first companies that really started to develop mega prompting. And so they were a legal solution, and they eventually sold to Thomson Reuters for $650 million. And those folks had been in the business for 10 years. They had already been building all kinds of solutions to make it easier for attorneys to find legal cases and information. And once they built their solution, they had near 99% level accuracy on all the legal reasoning and case cited and so forth. So you're not going to build that on your own. You're not. I mean, you can try, but the odds that you can compete with a group like that is unlikely. There are new AI solutions coming on the market every single day, right? So if you have a concrete use case you're trying to solve, the first thing to do is go find if somebody's already solved it and whether you can just purchase it. If you're doing highly custom things, and that potentially is also where the edge is, right? Then you have to you have an opportunity to start exploring yourself. And for each of those, as I wrote in there, think ahead of time: how much effort do I want to put in? How much time do I want to put in? What is the ROI? So a lot of folks will say, well, it's $200 a month for me to get access to ChatGPT 5 Pro, right? That's a lot of money, right? That people are, upset when Netflix is getting close to $20 a month. I get it, but your ROI on Netflix, I mean, aside from entertainment, is not going to be comparable to your ROI on ChatGPT 5 Pro or any of the other models, by the way, Gemini Ultra, any of those services where you go to the extra tier that gives you way more inference power, right? So basically it allows the model to work much harder for you. And you really have to think through, because the difference is real, right? So if you're investing that, you can even try it for just a couple of months and say, okay, I'm going to spend $400 on this, and I'm going to have these benchmarks to determine whether or not that $400 was worth it or not, right? But you really have to think about it ahead of time. And trying to go cheap, you have to understand that when you choose to go cheap, then your results are going to be, they're going to be capped at some degree. Now, I have all the models, and I have ChatGPT Pro right now, which I think is really where, if I have to choose to one where I'm going to invest that $200 a month, it's worth it, and I pay $20 for all the others. And part of the things that I like to do when I do my experimentation is that I will get an output from one model, then I will put it into the other model, and I will say, can you please assess this output? And then sometimes I will go and put it in a third model, and I say, give me an analysis of this answer. And then I would say, rewrite it, or, find what's wrong with this output and write a new prompt that will do a better job at getting what I'm looking for, and then pass it from one model to the other. And that has helped me to identify weaknesses in prompting techniques, and it's helped me to also identify certain errors that is easy to miss when you're working with complex topics that you're not familiar with. And explore with tinkering. Tinkering is at the root of innovation in business, as our friend Nassim would tell us. This should be a Venn diagram. Unfortunately, Claude, my prompting was, I did not have enough time to do a nice job on it, so I'll talk you through it. So you have automation of routine tasks, routine job. That's one big focus on LLMs. In enterprise, it's the number one thing that everybody's driving to, because capitalism, automating tasks has always been a thing, right? And so I'm not focusing on that. I assume that McKinsey and BCG have that angle covered, and I don't find it all that interesting. I recognize it will have value in the long term, but that there's enough people working on it. The second piece is augmentation. That is, can you start making people 10 times more productive at their job, as opposed to just getting rid of them? And then the third one is exploitation at scale based on the interconnectivity. That goes back to that kaleidoscope of knowledge concept that I had talked about, right? So what you can do with the LLM, and it's I'm so thrilled that we get to talk about it today, because I was in New York yesterday, and visiting a partner, and they have new ChatGPT ads in New York on the bus stops, and literally those new ads, totally brilliant, by the way, trying to steal a page right from Apple. Like, it's just a photo, and then it just says ChatGPT, and the photo tells you the story. And in one, there's somebody who's doing a workout and they're looking at their phone, and in another one is two teenagers who are whispering to each other. Another one, somebody's cooking, right? And another one, you have a young man, a young woman with the hood of their car open, and they're using the phone, and they're looking at it. So apparently they're broken out on the side of the road. And so absolutely brilliant ad campaign, because it goes to this element that we brought in our paper, is that the LLM is a two-way explainer, right? So basically, it can serve as a mediating translation machine, not just to languages, which it can do. And impressively, by the way, we have the now, near instant translation of languages with the new capabilities in the Apple earbuds and the Meta Ray-Bans. It's a pretty cool party trick right now to bust out your Meta Ray-Bans, put them on someone, and I can talk to them in French, and they just literally hear me within 1 second in English in their ears. But not only can it translate language, it can translate to anything. It will take what you say, right, in human language, and it will translate it into sophisticated input for whatever complex system you're integrating or interacting with, whether it is complex machinery, or whether it is the discipline of quantum computing, or whether it is the discipline of or 19th century philosophy, or whether it is cooking recipes or bartending recipes, right? All of these systems were evolved by humans using words and symbols, right? Everything that we do and that we have documented, we've documented it with words and symbols, and the words and symbols are connected, and they're connected before the LLMs even existed, right? Going back to our giant library, the only challenge that we had there is that there was the book covers that were preventing the knowledge from directly communicating or directly linking, right? But in the LLM, they are linked. So I'll give you an example of a simple thing that I did this summer. I bought a new smoker grill. And I don't know about you, but I cannot stand these written tutorials that are like 19 pages long with 100 warnings. They're literally written to give you a headache. And I was like, I've had it. I'm not doing it this time. And so I took a picture of every page of the manual for my smoker grill. And then I created a project in ChatGPT, which ChatGPT was 4.5 or the O3 model at the time. But with ChatGPT 5, it's even better. And I put on the advanced voice mode. And then I just said, all right, so look, I bought this cool new smoker grill. I need you to walk me through it. And now I had looked at the topics inside the tutorial, so I had a basic idea of what I should be asking about. And it was the most seamless experience that I've ever had. I mean, just fantastic. Literally coaching me through everything. And every time I had a question, I'd be like, yeah, but what about this button? And he would just walk me through it because he was a two-way explainer to my grill. But I've done the same thing, as I mentioned, with the Kant position. And you could, do fun experiments if you wanted. You could say, create an avatar that merges Buddha, the philosopher Hume, and the physicist Feynman. And your avatar is all three. And now I want to have a conversation with that avatar. Use only primary sources. Remember to always do that, because otherwise it will always go to the secondary and derivative sources. And that's very often people talking very ignorantly about what they've not understood. There's some insightful stuff there too, but going first to primary sources is my recommendation. So you can try anything you want because it's all connected in there, right? It's lossy. It's not perfect. You will want to challenge yourself. Sometimes if you think that it's really going awry in a certain direction, again, I say use the trick, take the output, drop it in another model. And the odds that 3 models in a row make the same error, very low, right? So it's a triangulation principle. But if you go at the intersection of these three, a piece of automation, a piece of augmentation, a piece of exploitation at scale, that is the ability to look across everything. So I'll give you an example of what I'm working on. I'm trying to do some tests right now. So I went to Gemini and I say, give me a list of 300 philosophers from across the world throughout history that are notable. And I got my list. So first of all, try to get yourself a list of 300 philosophers, unless you go rip it off some website. It's a lot of work. The second thing I said, and I put it in ChatGPT 5 Pro, and I said, okay, can you tell me what each of these philosophers has to say about consciousness? Just give me a brief summary. And then I had 300 outputs. And then I said, okay, can you now find some intriguing patterns that cross regions and time? And there it was, right? So again, do I just bundle that and say, hey, here's my paper? Of course not. But it's going to give you all kinds of avenues for exploration that, it would take you weeks, months to start doing all of that if you literally have to do it painstakingly one by one, or you would have to hire a team of 20 interns, which is really in many ways what an LLM is. It's like a team of 20 interns. So what we talk about is the Iron Man suit solutions. This is a concept that I started to put together with teams starting a few years back. We were in the manufacturing space, and the idea is you can now take that two-way explainer capability and you can start giving everyone new powers, right? The ability to move through information and knowledge and complex problems much faster, right?
Mm-hmm.
But that is where the human doing the exploration, the guiding, right? Using these powers is absolutely essential. And we have no agents that are able to do that independently right now. And whenever they run into edge cases and tail risk or tail problems, they can fall flat on their faces because there is no thinking there, right? So I'll give you a slightly scary example on that, conceptually, where you go, if you get blackmailed, I certainly sincerely hope this never happens to anyone, but suppose you get blackmailed, a human may successfully get blackmailed, like, somebody gets kidnapped, it's terrible. And they will come to you and they will say, okay, empty your bank account and send it. You may do that, right? Because you're forced to in the circumstance. But if they tell you, go rob the Federal Reserve and bring us the entire, or go rob Fort Knox and bring us the entire gold repositories of the United States government, you're not going to do that because you realize it's impossible. It's not going to work. And it's only going to make your situation worse. So you're going to start thinking about how to get out of the blackmailing situation instead of doing that, right? An LLM with instructions will go straight to Fort Knox because that concept is just not there. You have missed that function unless you have programmed it into a process for it. So the human is still absolutely essential. And when we're in that sweet spot for enhanced exploration, right? When we leverage the LLM as a two-way explainer to systems, when we know that everything's interconnected, so we can do exploitation at very, very broad scale. When we use the automation of, to save up time, right? To not have to do the repetitive and boring work. When we combine all three of those, we can be superpowered. So let's get to prompting. Again, folks, stop me if some of the stuff you know already. Again, what I'm going to show you is stuff that you can get right off of any LLM, right? So the main value of me bringing it up so we can discuss it in ways that are, hopefully engaging and consistent. But really, these prompt frameworks, are available in any of the models that have been developed by various teams. We could have an awesome conversation, maybe if we have the last 15 minutes, or with anybody who wants to follow up on this later on as to why these prompt frameworks work so well. And I've got a few ideas. But you have some standard prompts, you have advanced prompts, you have mega prompting. And then if we have a little bit of time, I'll give you a hypothesis on what we're working on. And I'm really focusing a lot of energy on, which is called semantic density prompting. So, one quick thing to go over last that I wanted to say, if you're interested in the concept of building these Iron Man suit solutions, my advice is you want to start pairing a domain specialist with an LLM solutioner. Now, you can be the LLM solutioner and the domain specialist if you happen to be a specialist in the particular domain you're building the solution for. But you need someone who has very, very deep domain-specific knowledge that can then validate the outputs as you're building your Iron Man suit solution with a two-way explainer system, right? So for example, if you're building a solution, my youngest, who's one of the co-authors on the paper and is now up at Northeastern doing advanced studies in AI interpretability, they're just about to release a really cool paper where they started to use Claude Code with minimal human direction to take any paper in that's the objective. They started with one, of course, where they were able to take a paper that doesn't have any code in the fields of applied mathematics called meta-heuristics, which is basically optimization for very complex problems. And they would get the LLM to understand the paper or process the paper. There's no human brain there, but it's able to process the information in the paper. And it was able to reproduce the code that was not in its training, because that code has never been released to the public, and achieve 90% state-of-the-arts performance, with just pure automation. And my youngest did this as the LLM solutioner, and he worked with a mathematician who was the domain specialist in the particular meta-heuristic called variable neighborhood search, right? So that was a very successful, and they had, of course, a guiding mentor or sponsor for the project. So if you're trying to build, an AI Iron Man suit solution to be a super powered, the super powered architecture, or super powered, innovative design, or super powered advertising, et cetera, et cetera. If you're not the one that knows the field to be able to assess, oh, this is what actually really works, it's going to be much more challenging. And be aware, if you get into that function too, is that the models change. They change quickly. New models come all the time. Sora 2 has just taken over the interwebs right now. So we're no longer seeing all the Ghibli cartoons. We are now seeing, if you thought we could not get more videos of cats, you were wrong. Except now you can get Pixar films of cats and dogs, and then some real bizarre stuff that's going to start popping out, very soon, including some hilarious stuff. I mean, you got to give it to Sam Altman that he definitely managed to take self-deprecating sense of humor to a whole new level. Because right now there are literally, tens of thousands of videos making fun of Sam Altman, and meanwhile he's selling his product. You got to give it to OpenAI. They have a pretty solid marketing strategy. So craft prompt template. It's called craft because you're going to provide your large language model context, a role, an action, a format, and then the particular tone that you would like. Now, craft is not the only one, right? There is rope, there is all of these functions that you see here, like the idea to give the LLM a role. There's not a person there that is like acting out, like it's not LARPing, right? Like it's what you're saying is you're giving it a semantic context to say, find information and knowledge in your generation of an answer that is relevant to or connected in the network to this role, right? So that helps. So for example, the word bank if you say, you're a teller or you're a financier, they will know to go look there. If you say you're a fisherman, then he will go look at the riverbank, right? So that's how these connections will come. Context, you have to provide background. The more, context is king. I will tell you that right now. I mean, that's the more context you provide to the model, and I'm talking, you can put a lot of context, like, 10 papers, or 50 examples, right? Some folks do that for really mega prompting. Now you can do simple context, and we'll see an example coming up next. And then the action, if you tell it the format, odds are it's going to produce it in a way that is going to be more useful to you. Tone is, again, that's necessary only if you actually care about that. If you're doing business outputs, for example. But again, there are different versions of this framework that are available that don't care about tone, but we're just using this one for today too, as an example. So I'll give you here this example, and obviously, I didn't just sit there and write it and made it up. I asked Claude, in this case, to provide this for all of us. So here's the thing. Context, I'm a marketing manager and I'm preparing for a product launch. So I'm explaining this is what the context is. And then there's going to be an action that you have to perform in that context, right? And the action, is going to be related to what a senior data analyst would do. So let's make sure that we, are giving you that role. Then you give the action, the format. You say you want, in this particular case, 3 concise bullet points, and tone, professional, and data focused, right? So you can now take this notion, right, this framework here, and start using it. And what I'd like to do with folks in general is try a 1-sentence prompt, see a result, and then you don't need to do all this work, by the way. You can take your 1-sentence prompt and tell your model, write me a craft prompt for this 1-sentence question that I have. Then you will write the craft prompt. Then you should edit it. And then run that craft prompt and compare your result to your 1-sentence approach. And you'll get to see the difference yourself. And again, what's great about that is use the LLMs to help you develop your prompting. Now, when you're doing mega prompting, it could be a little more challenging, but you can really leverage a lot from them. On the context piece, however, you have to direct it, right? You have to provide as much direction as possible so that it actually understands the context. If you just let the LLM, run on autopilot finding the context, at some point it's going to start drifting towards whatever bias or statistical noise is involved. Now, you can go a little deeper into that. And so this is called the React prompt template. And really, if you go back to React, this is really the beginning of what we have come to know as agents, right? It's a set of instructions where you're really telling the model to perform a set of actions that is continuous. So it's doing a job, and you're giving it access to tools, as you can see here, right? And so you would, it's going to be a pretty long prompt, right? And again, I'm giving you the example here. I'll share the slide, but you can just go type in any of your models that you use with today saying, hey, I want to start to use React. There are other techniques, by the way, tree of thought, which allows you to do branching exploration of topics. And so you could say, for example, hey, I'm using React, I'm using tree of thoughts. What other interesting prompt templates are out there? The model will start introducing you to them, right? And then you can pick which prompt template will best serve you for which purpose. But in this case here, right, you're giving a thought, action, an observation, a repetition until a solution that's been predefined is reached. You're giving it available actions. Do I have the, yeah. And then you give it literally the thought here, always follow the thought, action, observation cycle, be explicit about your reasoning. I'm hoping that they kept our, I don't know if the crafting just got erased. So maybe, but lucky us, we have a little bit of time. So maybe we'll run a React prompt and watch what happens. And then the last piece I'll bring up is the mega prompt, right? So an example of a mega prompt here will really, that's where you start thinking about investing a substantial amount of upfront effort to get an output that's going to be, both deep and broad in its informational value to you. So here again, you could see the example of the mega prompt would be, oh, you're, an elite content strategist and creator with deep expertise and so forth and so forth. These are the core competencies that you have. Here's phase 1 of what I need you to do. Here's phase 2 of what I need you to do based on what you've done in phase 1. Here's phase 3. I want you to move to content creation, right? And so your output format will say, okay, when you create the content, you're going to provide it in this. Give me a strategic context. Give me a, complete content and so forth. And then here you see the interesting thing when you give it interaction guidelines, you can say, hey, when you're running into issues, trying to solve this problem for me, come back and ask clarifying questions. And you'll notice, by the way, that when you're doing, if you're using deep research for Gemini, or even the researcher agent on Copilot, if you're in enterprise, that when you make a first ask, it will immediately follow back and tell you, hey, here, I have a couple of clarifying questions for what you're trying to search for. So this is really taking some of these elements from React or Mega Prompting and putting them into an agentic framework, right? So deep research is an agent, is really what it is, right? But it's really based on this original thinking. We've got an hour. We have about 30 minutes left, if I understand correctly, or 28 minutes left. Is that right, Sangeeta?
That's correct. Yes.
So I'm gonna talk to you guys about one more thing that I'm trying to explore with the semantic density prompting. That's going to be quick, and then after that, I think it would be really super helpful if we could open the floor and make this a little more interactive, and then maybe try a test or two and see what happens. Semantic density prompting. So based, again, for anybody who's interested in the paper, and I'm going to put it as soon as I can locate the chat window. Chat, where is the chat? Zoom. Oh, everybody can see my Zoom now. There we go. And no, it's not going to accept it.
Oh, I did send you a chat, like a message on chat, though, so I think it probably highlights it.
No, I'm trying to give you guys the here type. There we go. It worked. So that's the paper, in case somebody wants to read it. And if you find it too challenging, I mean, we've done our best to really write it in the most accessible way, but at some points it may get a little thick. Take the paper, drop it into one of your favorite models and say, explain this paper to me. And ask questions. But so one of the, based on our concept of the LLM as this vast multidimensional interconnected search space of all knowledge, we raised the idea that in the corpus of training data, right, it's trained on quote unquote all the internet, and then all digitized books, and then all printed and published articles, et cetera, et cetera. We raised that the both in the training data, you have a power law distribution of informational value, and that in fact, in knowledge itself, this already exists. So if you go back to our giant physical library with all the books that actually have covers, not all books are equal. Not all scientific articles are equal, right? Again, we could look at the enormous impact and power of an article like Einstein's article on relativity versus, your average output from, a first-year PhD student who's just publishing because they got to get an article written, right? So you have a power law distribution, and we surmise that power law distribution is mapped out into the neural nets of the LLMs during the pre-training process. And so that in our prompting, one of the things that we need to start figuring out is how to access the long tails of the distributions that are mapped out where we have the most informational density. And then we need to figure out how to activate it. And so I'm working on that right now. I don't have anything really fantastic to share quite yet, except that I can tell you we've done some fun experiments using the Dewey Decimal System, because there was a system that was created to identify what shelf books belonged in the physical libraries of the United States. And so if you just output and say, here, I have a question, let's say on philosophy, specific this, and I'm like, focus on these numbers for your search, and I put the Dewey Decimal numbers, I get a very different output than if I don't put those beacons, as we call them, at the front. So, when Sangeeta organizes next year's AI Summit, I'm look forward to coming back with some more concrete results on that front. And then let's open up the floor and see if we have some questions, interesting use cases, stories anybody wants to share that are relevant to the conversation.
Sure, absolutely. Yeah, Mithil, go ahead.
Xavier, thank you so much. This was absolutely amazing. And one use case that I have in mind, and I just want to pick your brain on how you'd approach it,
Sure.
is there are, as you know, I'm into trading stocks and commodities, and a lot of times I see videos on YouTube describing certain trading strategies or certain thoughts. And my issue is always like there's so many of them, I don't really have the time to extract their code logic, turn it into code, and just automate the backtesting and see if whatever strategy the person is pushing, what real results are, right? And I'm not being able to figure out a good way of doing it. I've tried a few things. Some of those things half-assed work, but
So
if you were to go with like your
where are
prompting
your pain
approach, how would
points?
you do it? What's that?
Where are your pain points? So you've tried to, so where are the pain points?
So extracting the logic and the actual trading, ideas or strategies from a video. A lot of them, sometimes use charts, sometimes use lots of verbal description. There's a lot of fluff in there. That has been my first thing, is like if I just feed it to say a summarizer, it summarizes the text, but it really doesn't get, okay, this is, the trading strategy, right? So I don't know how best to just extract the logic out of it and then say, okay, now feed it to the next step, go to Claude and then code it.
Yep. So you have three different, right? So you break down the problem, right? That's what I would recommend. And then again, develop a strategy and then start vetting your strategy with an advanced LLM, right? Where you're going to start challenging the elements of your approach. So I would say first start with a few videos where there is a strategy and you actually understand how to implement it, because those are your examples that are going to be your test to start establishing a multi-prompt strategy that at least works on a small sample, right? And so you have to find the best way to get the best output from the videos. And you could potentially say, you're going to have to find a way to establish criteria by which you automate the download of the information from the video, and you provide your prompting filter that will determine, yes, this is worth implementing, no, this is not worth implementing, not based on the success of their strategy, but on whether there is enough information that is clear for you to do it. Is it actionable or not? Right. And since there's lots and lots and lots of videos out there, you still can get some content to start with. Now, unfortunately, we may find out that the most interesting trading strategies are the ones that are presented by people who are most inarticulate. We don't know. I have no idea whether there is a correlation there. But once you get that done, so the best way that I would approach it is that you need to create a prompting context for each of those tasks, and that's a different task, right? So just like when you go to Claude Code to do the actual coding, you need to create a prompt that has a context and a role and a function, or potentially a semantic density approach that says, how do you find a signal in the video, right? That basically allows you to extract the strategy. And then you should have a different role there that's going to say, do we understand the strategy and how do we translate it into a set of requirements that we will then feed to code to actually code it? You probably have three different functions there, right? You do the scrape. So I assume you have that gotten together, but you have to validate the quality of your scrape. Then you have to look at, can I identify what the strategy is from that? And then can I turn it into requirements that I give to my coding agent? And each of them is what role. But again, what I would do there is write down this process and then put it into an LLM and say, give me a critique of this approach. This is my goal. This is my objective. Is this approach going to work? And when you get that output, you go drop it in another model. You say, hey, this other model said this, but I think it's probably not as good as what you're going to tell me. Right? And the last piece on that I would say though is that you're talking about something that's very advanced, right? If I were to tell you 6 years ago that there was some kind of magic Iron Man suit that you could put on to do this, you would have been like, no, you're crazy. That's scientific. So what I would recommend is break down your own process when you do it, right? So do it for one video. Document your process, right? Say, so I watched the video. How do I identify and where do I identify what is the trading strategy? How do I write it down in a coherent way that I can code, right? And then you can also use those instructions and give them to an LLM and say, this is the process that I follow. I want to automate this. That's the best way to go about it. That would be where I would start.
Yeah. And of the prompting frameworks that you went through, right, like React or Craft, which at a high level, which one do you think would probably be fitting into this template the best?
You would definitely want, I mean, your Craft is your basic start to it's super simple, right? I would say that React would probably work quite well because you have to do iterative elements there. But again, I would suggest, you at the end, you're probably going to end up with a mega prompt. You should build that with the LLM, right? I just saw a fantastic post today on X where this guy explained how he built a full-fledged marketing ad production agency with 5 different tools, like using, Midjourney, and then he would go to Claude, and it would come up with a prompt to get a whole bunch of, they would put in a product, put in the product's description, ask, give a role of a marketer with a whole bunch of context, do all the research on the market, then come up with 50 ideas for video ads. Then he would automate the generation of all these ads. Then he would create an agent that says, look at the market and assume that you're a market analyst for sentiment response, create imaginary audiences, have them watch this video and give me their responses. And fully automated process to start selecting the best candidates that he's going to put out in the real world. It looks very impressive, right? So again, it's a question of breaking down every one of these processes. Like, think of it like you're running the company. One of the things that I like to do, and I see Kyle's got his hand up, so I'm going to be very tempted. But I would say this, right, is imagine you're doing this 10 years ago and you have a substantial budget to do it, right? Somebody has given you $10 million. You can hire people. How would you do it? Right? Who are you hiring and what function are they doing? Break that down, write it as a story. You can even go to the LLM and say, hey, do I need to write a mega prompt to accomplish this? Or should I do a series of prompts? Should I do a multi-agentic approach, right? Just get and engage with the kaleidoscope and start getting that feedback. And then, generally, try to talk Kyle into it and then have somebody do it with someone else. Generally, really awesome.
Yes, the pairing with the domain expert. I think that is a key idea here as well.
Kyle, what's up?
So I wanted to interject, from what you're specifically talking about. I've spent a lot of time thinking about, and the information entropy of a signal. So let's say there's an option price that's particularly rare. The problem that we have is, or at least historically, what we were talking about 6 years ago, is we couldn't look at all the option prices effectively.
That's right.
So the very first job is to just have some type of, for the specific strategy, an ordinal value system. So you've got to have like a Python backend that's being fed data. Then Excel Wings feeds it to a dashboard on Excel. And then you could have feasibly an agent looking at multiple Excel sheets that
That's right.
lifts that up to an AI dashboard. So then you can have every one of your strategies being monitored, and you only have to look at the ones that make sense to you right then, because you have two filters and it's all based upon the information entropy of the signal. Why look at anything but A+ signal?
Exactly. And what's so great about that is, so you're really talking to the points that we talked about earlier, right? So you're doing exploitation at scale, right? You're able to process way more information, and then you're creating filters. So you separate signal from noise. And noise, I don't mean that it's wrong. I'm just saying that it's just uninteresting from your perspective. Like those are the options I'm not interested in. And then what you can even implement there, if you know about our good friend Marco and his Schrodinger's cat approach, right, is that he's got criteria. But I would always say to Marco, is like, how many stocks can you possibly monitor for this criteria? Well, you can now, action a strategy where you can put very sophisticated criteria, which is what I was just telling Marco on a call recently. Is like, you can now use Grok to say, hey, I want to find every stock within this particular price range with this much, within this particular band of trading from, for volume. And I want to find the ones where most of the mainstream analysts are, tepid, and there's a couple of contrarians, and they have a thesis. And you can say monitor the following 200 accounts on Twitter, and you can pull that out, right? And then you could say, if you find that criteria, move to step 2. Step 2 is, can you find strike prices that are high enough that it meets my particular criteria, that I think that I could get 30x, 90x, their leaps, their et cetera, et cetera. So you can do a multi-phase thing where you filter, and you could even make it fun. Like every time you get a candidate, it goes like, boom. And you go like, oh, let me go look at this candidate, right? And it could be something that's done continuously. But your point is exactly correct, and it's and again, what's fun about that, right, Kyle, is that you're basically saying you would need a firm to do that 6 years ago, and you can do it potentially without a firm today. Now,
yeah, very true.
As with all things investment, the second it's action like that, well, you got to assume that unless you're exploring something that is your own IP, right? You've explored a new category of idea, a new approach, something that is outside of the mainstream thinking. If you're sharing it, or if it's easily findable, you got to assume that somebody else is going to start doing it, and then all of a sudden it becomes the baseline. That's another problem. I don't think you're at risk of that, Kyle, because you're far, far ahead in your thinking than most. And I've never felt a lost minute listening to the super interesting guidance that you provide. Does that connect with your comment, Kyle?
Yes, I think that that what you were saying with kind of links with what people say. It may not be what they know, and what they know may not be what they say.
That's right.
So it's really interesting. Some of the best experiences I've ever had were in quote unquote like paid internships, where you go and trade with somebody and you just mimic their trades. You can then write down the rules as you see it then. right? And it's nothing, you know, because a YouTube video is not going to give you the edge cases. But when somebody's in a major pickle in a trade and they're like, well, yeah, when this happens that 1 in 1,000 times, you do this. And
Yep.
that's really the most valuable information that you could ever get. And it's well worth paying people and then you writing it down and iterating it. And it's really goes back to that whole atomic habits kind of epiphany that it's the 1%ers that separate us because we're in a Pareto distributed world. Like in movies, you know, it's not that the movie's like 1,000% better, even though the sales may be 1,000 times greater.
That's
It's
right.
just a few percentage points that shift it. And if we get those few percentage points in edge, compounding the growth rate of our geometric wealth growth is it's, you know, you can sit and do the arithmetic. It is a big difference.
Very big difference. And so the interesting thing there is that, you know, where LLMs are not going to replace that, right? Like, you know, some of that information is captured. Finding it is going to be very, that should be among one of the most challenging semantic things, because he's basically saying, of all the knowledge that you've ingested, where are those books who have not been read by enough people but contain super valuable things that somehow are stored in your deep neural net? But what you can do is do that exploitation at broad scale, right? Where you can test so many different ideas. And if you know how to read signal from noise, you can discover, you know, some actionable concepts that others may not have thought about. But that's not going to replace, you know, exactly what you said about, you know, the richest. I mean, again, there's a reason why humans, you know, are the explorers, right? It's you know, that person that didn't blow up when they got into that pickle and figured it out. I mean, you know, they may have blown up a couple of times, or not blown up, but suffered tremendously and learned from the pain before that. Or they may have been part of a team where 20 others blew up and they're no longer around, and it's the one person that figured it out, right? It's a phenomenon that's you know, totally unique to the human brain. So again, to me, and you know, I will always give this message for folks who are, you know, worried about the AI apocalypse. You know, we don't know what's coming 5, 10, 20 years from now, and we don't know what humans with automation are going to do to each other. And if you look at the battlefronts with all the drones right now, it's, you know, there's some pretty grim stuff out there. But for now, really, you got to think about what is it that your brain is uniquely good at doing, like thinking, oh, I'll get a patent internship and I'll observe how these pros do, and I'll identify when they're doing something special and I'll write it down, right? Those things are unique to the human brain that is activated, right? And agentic. So how can you use this new technology, right? This two-way explainer technology, this exploitation at scale technology, to make those parts of my brain 10 times or 100 times more powerful? We got 5 minutes. Anybody else?
I have one unrelated question, or just your perspective on it. The way I view LLMs and prompts is the quote unquote pre-training is a high dimensional space. Like, let's just say it's an n-dimensional space. And I view prompts as a hyperplane, an n-dimensional hyperplane that we're creating a space for the algorithm to sample from, and creating a space that is excluded. Would you see it from that perspective?
Yeah, I think that's an excellent way to think of it, right? What I mean, it's a hyperplane, you know, I mean, visually it's helpful, right? So absolutely it is what you do in a prompt. And one of the reasons, by the way, one of the techniques that we didn't quite go into on the prompt that you'll see in the mega prompts is you have to tell it what you want. It's also really smart to say, this is what I don't want. Creating exactly that hyperplane that you're talking about, Kyle, right? But when you activate with a prompt, you're directing it through features and circuits, as they call them, in the model, where it's gonna go and look and make these connections and not those. That's exactly right. But the question that then I ask is, what is this neural net built upon? And what is the hyperplane that you're creating, right? And I think that one of the things that is an interesting debate for the moment is that most of the industry has been super focused on the model architecture. They tell you it's just a capability of the neural net. And I'm not sure that I buy that. I think that the neural nets are incredibly powerful, but there's a reason why LLMs surprised everyone, including Richard Sutton, who was he was just telling this on the Great Dwarkesh podcast just this past week, that he was surprised by how good LLMs were. And I'm like, well, that's because LLM are built on knowledge data. It's a super rich data set. It's not the same as photos. It's not the same as chess games. It's not the same as, prior data sets that you used. So I actually think that multidimensional plane is heavily constructed upon the semantic relationships that already exist in human knowledge. And that the hyperplane that you create with your prompt is actually activating some of those capabilities. Now, it's a hypothesis for now, but I'm working on activating it and testing it. And if that's true, one interesting aspect of that is also that the human brain is the mediating agent that we use to create language in order to have such a thing as written knowledge. So you actually have three potential informational structures, and some of that stuff then goes to Stephen Wolfram and Mandelbrot, who I reference in the paper, where you would have an informational structure in the universe, and then there's the human brain that captures this information and then decides to find a way to encode it. Then it's encoded in written knowledge, influenced by the way the human brain has perceived this external information, and then it gets mapped out onto the LLM. And we have much to explore. Like I said, I might be able to come back a year from now with some super fun stuff. Rashad, did you just open up? Oh, that might have been accidental. Well, folks, we're at our time. Sangeeta and Mittal, thank you very, very much. Thank you, everyone, for giving me this opportunity to speak with you about these concepts. And I'm easy to find. If people want to follow up, and Mittal, it's an interesting use case you got. Let's see if we can explore it some more.
Yeah, maybe.
I'm working on a next paper, right? So I'm trying to identify 5 completely different fields. So we're going to do math, we're going to do philosophy, we're going to do coding. Maybe a finance one might be a nice one, where I want to start exploring the existing best techniques for prompting, but then try to understand what's the semantic content that's involved.
Only if Kyle agrees to be the domain expert I can lean on.
Yeah.
It's a great idea. I think we should explore it further.
Kyle has reached this level in life where people would pay him to intern with him.
I know, right? Kyle, are you offering paid internships?
I'm here to share. My friend. It's all about service.
Thank you.
You are an incredibly generous guide. Thank you. Thank you very much, everyone.
Thank you so much for this
Next time.
awesome conversation. It was great. I think everyone enjoyed it. And thank you so much, everyone, for
Take care,
joining us.
Bye-bye now.
Bye. Thank you. Oh, wow. So that's it. 2 days, Practical AI Summit done. Oh my God, you ever notice how this conference day one, everybody excited, coffee in hand, big smile, lot of energy? By day two, you have got about 47 tabs open, 3 half-written emails. But here's the thing, over these 2 days, we didn't just talk about AI. We saw how it's been used. That's where the fun begins. Because even if you don't work in that industry, you can still put lessons and parallel on your own. Like Kyle's talk about decision filters. You may not have to run a resort or a wealth management. We are all making too many decisions every day. What if AI helped you filter that noise, email, reporting, meetings, so on and so forth. Harry's talk about governance and so much documentation. How AI Grantha can actually be leveraged that technology to put this together, put it in structure that you can interact with and know more about. Same thing, there's so many things out there. Like Dennis showed us how structuring a modern AI team. Maybe you don't even have an AI team, but the lesson applies. Build cross-functional team, balance vision with execution, and so on and so forth. Like there was amazing talks around, and I'm like blown away. Now the summit may be ending, but the real work begins. Take the insight, the aha moments, the conversation you have, bring them back to your team, your organization, your community, because the measure of the summit isn't it what's happened here, it's what happens next. We are not done. We'll be back with more of these gatherings, going deeper into different verticals that matter most to all of us. Do share, asking for a favor to please take this survey, give us our feedback, give us your feedback, because this will help us get better, organize upcoming meets like that, catering to your feedback. And on behalf of the organizing committee, I thank you for your time, your energy, your curiosity, for proving that AI can be practical, impactful, and yes, human. Thank you, everyone. I'm just going to share the screenshot of the QR code for the feedback. We have a happy hour in another half an hour. Do join us there. It's a different Zoom link. We'd love to see all of you. I didn't get a chance to see, just saw the names, and have some good conversation there in terms of, learn a little bit more about your business, what you learned. So I'm just going to share real quickly. Let me know if you can see my screen. Yeah, we'll do a lucky draw of everyone who has submitted feedback to us, and we'll announce the winner during the happy hour. So please fill this up before you join us in half an hour at the happy hour.